zone in the middle where they can kind of relax, and then right outside that zone, they're just kind of there's a noticeable pull towards the outside.
Well, I did not notice that.
Yeah, just gotta pay attention, man. You could
So
get
are you
fooled out
saying
there.
you believe that if I take just a little neutral buoyant thingy and put it in the tank, that it will be pulled to the outside?
Uh, no, because I don't think that the surface is gonna do the same thing as what the medium below the surface is doing.
Well, let's say I have
I
a
don't know if
neutral buoyant thing like a fish. Fish are basically neutrally buoyant, right? So let's say I take a neutrally buoyant thing and I put it a couple inches under the surface, like a goldfish would be. And you think it's going to get pulled out to the outer end?
my Bluetooth that I had to switch over. Yeah, that would be kind of an interesting one to see. Having something that was completely buoyant, neutrally buoyant just below the surface, and then just to kind of see what the different levels are doing. I'd like to see that.
Well, what if I just take a and squirt a little bit of food dye about 2 inches down to put a marker in the water?
Yeah, maybe that wouldn't be a bad idea either. To kind of showcase what the water's doing.
I mean, the water is neutrally buoyant also, so if I just dye some of the water, and if there's a force causing neutrally buoyant something in there to move, then that would cause the water to move and the dye, right?
Yeah, you know,
So let's see.
you never put water in like a 2 liter soda bottle and like spun it around.
Can't say that I have. Not the same
Really?
direction. I mean, I've shaken them by spinning them, but back and forth, you know.
I mean, this is like freaking first grade type.
So what's your prediction for the projectile?
I see. There's people saying that if you rotate the medium with the ground, that you won't get the Coriolis effect.
The Cornelius effect. Yeah. The one where the Atmos is in lockstep sometimes, then it isn't, then it is. That one?
People are saying people are saying if the medium, yeah, people are saying if don't have the Coriolis effect. So Jess is going to try to do it in a fish tank.
The old fish in the fish tank. Uh huh.
No, he's going to shoot a little torpedo thing out of somewhere in the water of a rotating fish tank. And then he's going to record it from when like MIT does, how they record one where it's rotating, one where it's not rotating.
I see. Okay. So is the water going to be rotating in lockstep with the fish tank?
Yeah, it's just going to be a rotating fish tank, bro. Yeah. Picture spinning a glass of water. Like all the water just spins with the glass. There's not even any movement of the water, really, so to speak of, compared to like the glass, right?
Hmm?
It might bulge towards the edge, but it's not going to be like, there's not going to be like any flow or anything, you know? Once it's all spun up. Now Elbow's saying it's got to go straight in the inertial frame, but that's a whole nother argument because it doesn't have to go straight in the inertial frame. You know what I'm saying? You could go straight in the non-inertial frame and then curve in the inertial frame. That's an option. That'd still be Coriolis.
What's the non-inertial frame
The one that's
in a
neither
fish tank?
the one that's neither accelerating nor rotating.
Oh, it's the one that's rotating, the non-inertial frame, the
Oh, right,
rotating
yeah.
one.
And what's the inertial frame?
That's the one that's neither rotating nor accelerating.
Yeah,
And where will you get that?
from above. Just like MIT does it, bro. You ever see how MIT does it? They'll film it from above. One camera is rotating, and another camera is not rotating. You know what I'm saying? They'll have one camera attached to the thing that's spinning, so it's that's also spinning with it, and then they'll have another camera not spinning, right at the same spot.
Yeah, but what's happening in the fish tank? It's always rotating. The fish tank is going to be rotating, right?
Right. We're into dizzy fish.
Yeah, the fish tank's rotating. You're gonna shoot something that's gonna go in a straight line in the non-inertial frame. In this instance, instead of like when you throw a ball off a merry-go-round, how the ball goes straight in the inertial frame. In this one, it's going to be straight in the non-inertial frame, and then in the inertial frame, it's going to be curving. Which Elbow is going to try to say that that's not Coriolis because it didn't go straight in the inertial frame, but that doesn't really. People just use that as an example because it's easy. You know what I mean? That doesn't mean it doesn't have to. Like if SE, say you were to throw a curveball instead of just a regular straight, throw the ball straight. Say you were to throw a curveball off the merry-go-round while it's spinning, you realize the Coriolis effect still happens, right?
Well, the ball would be curving then because of the ridges on the ball.
So you're saying no Coriolis?
Well, Coriolis really, if you think about it, is a visual effect. And
Well,
people here get mixed up that it's an actual thing, but it's not an actual thing. It's a visual effect. Does everybody agree on that?
I wouldn't say it's visual.
I wouldn't say it's
You,
not a thing. It's definitely a thing, and it is visual, but
I mean, you could have a
No.
magnet in your projectile, and then you could have magnet sensors gridded underneath the surface it was trajectorying over, and those magnetic sensors would record it going in a non-straight path if they were on the rotating frame. So I wouldn't say it's strictly a visual thing.
Then you don't understand it correctly.
I'm with you though, Essie. I'll say it's a visual thing. Yes, In one frame, it looks like this, and another frame, it looks like that.
Exactly. The actual thing that's happening is the ball is traveling in a straight line.
Unless you, in this scenario, we threw a curveball, though. We didn't throw it in a straight line. We threw a curveball
Well, that's
off the
different. Yeah.
merry-go-round.
Yeah, that's
So you're
different.
saying that's not the Coriolis effect now?
I
No.
think that would be
Oh,
Coriolis
God.
effect minus Magnus effect.
No, it's the Coriolis. It's still the Coriolis effect, dude.
Are you talking
When
about
you
a
throw a
curveball?
curveball, that's a Coriolis effect? How so?
Yeah, you throw a curveball off the merry-go-round, right? So that's going to have one path. And then when you view it from the non-inertial frame, it's going to have a different path.
So
It's the Coriolis effect.
what makes a curveball curve, Jeremy?
Well, in this instance, we're going to have a pitcher that knows how to throw a curveball, throw it off the merry-go-round.
Right. What physics phenomena makes a pitcher's curveball curve?
I have no idea.
Okay, I'm
Magnus
telling you.
effect? I don't know.
There
Ridges.
you
The
go.
ridges on the ball.
Yeah, it's acting upon the air to propel itself. So that's not Coriolis. That's propulsion.
No, we're throwing a curveball off of a rotating merry-go-round. So the curveball in the inertial frame is going to have one path, and then in the non-inertial path, it's going to have a different. And the non-inertial frame is going to have a different path.
Well, a curveball is not a trajectory. It's a flight path because it's exerting side forces on the air to change its trajectory. So it's not just inertial motion. It's actually acting upon the air to change its path.
All right. So if something doesn't go straight, it's not the Coriolis effect. You realize that rules out everything. Every planes aren't affected by the Coriolis effect now on Earth, right?
I don't know where you're lost off to there, Jeremy.
Well, you're saying it's got to go in a straight path. So when these guys claim that they're correcting for the Coriolis effect and they're curving, they're not going in a straight path in the inertial frame, and it's not the Coriolis effect anymore. That's what you're
Yeah,
telling me?
I have no idea what your point is with the curveball. What about a drone? Let's take a
My
drone.
point is that if you don't take a straight path in the inertial frame, you still have the Coriolis effect.
Coriolis effect, we just went through it, is a visual effect. You throw the ball, you throw it straight, but because the rotating platform underneath is rotating, it appears to be curving. It's a visual effect. When you throw a curveball, it's actually curving. You understand? It's not the same thing, bro.
It is the same thing. It's just a different path. It's going to be two different paths, dude. Okay, well, let's say I throw a curveball off a merry-go-round, right? And then we trace the path in the inertial frame, and then we trace the path in the non-inertial frame, and they're two different paths. What would that effect be called? If it's not the Coriolis, then what is it? What's that effect?
Is it a
It's a
thrust
good
vector
question.
influenced path?
Yeah, the whole thing of the Coriolis is the ball has to be traveling in a straight path, bro.
No, it
Just like the
doesn't.
pendulum, yes.
Yeah, but it's about actual rotation, not.
Exactly. That's the main point. There has to be a rotation involved. Exactly. And first, you got to prove that the Earth is rotating, even to talk about this effect. So if you throw your ball, Jeremy, with no rotation, it's just a ball curving, like it happens on
Yes,
Earth every day when a pitcher pitches it.
and then we view it from okay, so that has one path, and then we view it from the non-inertial frame, and it has a different path. What would we call that effect?
Not the Coriolis. Call it whatever you want, but it's not the Coriolis.
Jesse, you agree with this?
You
It's gonna
lost
make
me. I don't understand what you're saying. I can neither agree nor disagree because I don't understand what you're saying.
We're saying if you throw a curveball off of a merry-go-round that's spinning, and from the inertial frame it has one path, and then from the non-inertial frame it has a different path. What's that effect called?
A thrusted flight path? The curveball is pushing off the air in a sideways way in order to cause it to deviate from an inertial trajectory. It's not flying an inertial trajectory, it's flying a flight path. So I'm not sure what your point is.
I'm
Do you
saying
know that
there's the Coriolis effect is there. That's going to be a serious issue for planes now if you're saying that's not the Coriolis effect. I'm just letting you
are
know.
you, are you asking if you could use vectored thrust from the spinning of the ball from the Magnus effect to counter the Coriolis force to cause the ball to follow an inertially curved path that appeared straight from a rotating reference frame?
Yeah, you could phrase it like that. Yep.
Okay, and that is why jets flying east or south, north to south or south to north have to bank slightly one way or slightly the other way to provide an offset to that very small Coriolis force.
Nothing is banking, bro. There's no banking involved. That's what you
Well,
just believe.
Well, no, actually, and I wish I had saved it or I could find it, but I actually saw a write-up about a very, very slight difference in banking angle on northbound versus southbound flights. So there you go.
It's all a belief in your head. The earth is
Uh,
not spinning. There's no Coriolis. There's no banking of planes.
well, I mean, we do know that sufficiently precision gyroscopes do show 15 degrees per hour apparent drift, right?
Just like your pendulum.
So how's that different from Coriolis? I mean, that's just a moving mass, and it behaves as if the platform is rotating very slowly, right?
That hasn't been proven. That's another parlor trick.
I tested it with three aircraft gyroscopes, and all three of them all showed 15 degrees per hour and all in the same direction.
You can believe that if you like.
Well, I mean, I did it, so I know it. I don't have to believe it because I know that. I tried it, and that's what they did.
Sure.
Speaking of gyroscopes, I believe you accepted that my most recent test did meet your what you had in mind for the test, and I believe we had a deal there. Um, so I think we need to wrap that up. Unless you want me to do it again live on camera or something. If you think I'm cheating, I can do it live on camera, real time, live stream it, and then when I'm done, I can take it all apart and show you what's all in there, just in case you think I'm cheating somehow. That blue tape comes off pretty easy. That's why I use it.
Assuming you did it correctly, all you showed was that that particular gyroscope isn't sufficient enough to show. It cannot hold its rigidity in space. So that's all you did.
Is that not exactly what I needed to do to satisfy your request, your challenge, your offer?
Well, no, it was. I was assuming that that gyroscope would be precise enough to show it. So, are you saying that if you had a good gyroscope, a precise gyroscope, that it would not show what you showed there?
Correct. Yeah.
Assume.
If I had a
Sorry.
gyroscope that had if I had a gyroscope that had a very low friction bearings in the gimbal and ball bearings, roller bearings, not just friction bearings like this model has, And if it had a larger flywheel, possibly spinning faster, and it was balanced real good, it would then show the 15 degrees per hour.
Okay, so all you showed was that that gyroscope was not sufficient enough for it to do what I said, for it to keep its rigidity in space.
Right, and that was your bet, that I could not show that, but I did show that, right? Whoa,
Yeah,
isn't
but I
that
was
right?
assuming that the gyroscope would be precise enough to show that, Jesse. So obviously it wasn't. So you just admitted yourself. If you had a precise enough gyroscope, the rotating wheel would not stick to the base. So, I mean,
But the bet
do
was
you really
about
think you won anything there?
this gyroscope because, and if you go back and listen to the recording, Zanuck was telling you, everybody was telling you that this model of gyroscope did not have sufficiently free-moving gimbal bearings in order to track slow rotations. And you bet that it would. You bet on this specific gyroscope. In fact, this specific unit that I had, because they brought up the one that I had on the Lazy Susan, and you remembered the Lazy Susan. You're like, oh yeah, the one that Jesse did on the Lazy Susan. And then he says, but I bet you $1,000 if you take and tip it up the other way instead of rotating it, that it would track. Is that not what you bet?
Maybe I misspoke because in my mind I was thinking of a precise enough gyroscope to keep precession, you know. So maybe I misjudged what the bet was, but obviously it would have to be a precise enough gyroscope for
Well,
it to not glue to the base.
okay, we went over it very clearly. I says just so, and it's all in the recording. I said just so we know what we're talking about this UK-made super precision toy gyroscope that I had already used on the turntable. You had seen it. You knew what I was on the Lazy Susie. You knew what I was talking about. What maybe you misunderstood physics, but that's not my fault. You still made a bet.
I didn't misunderstand physics.
Well, are you willing to go over the recording and see if you recognize that I did fulfill what we agreed to, what you agreed to?
Look, man, if you really need the $1,000, if you're really so depraved and you wanna win the bet on a technicality, no problem, bro. I'll send you the money if you're really that desperate for it. It's not a problem.
It's not a technicality. I want it fair and square. Cool. I will get a P.O. box because you said you'd send it to any P.O. box. I also have PayPal and stuff, but whatever. You said a P.O. box, and if that's what you require, I can get a P.O. box. But I want to put the money towards building a new, bigger gyroscope that does have the right kind of bearings and moves much faster, spins much faster.
Whatever, dude. If you really need that money, like I said, get me a PO box and I'll send you the money. If you're that desperate in need of it, no problem.
Yeah, but the
All
fact
right.
that those gyros all show you the same direction shows you that you're really following the westward drift of Earth's magnetic field.
All right. Well, thank you. I will get a P.O. box, and I'll let you know when I got it.
Sure, dude. But you do concede, though, that if you had a proper gyroscope, it would do exactly what I said, right? You're only winning on a technicality because of this particular gyroscope. You admit that, right?
Well, it's not a technicality because your bet was on this particular gyroscope. We before the bet, we all told you that a proper gyroscope would track the slow rotation. Your bet was on this gyroscope, this exact model. In fact, the one I have, because this gyroscope doesn't show Earth rotation. you were arguing, or flat earthers have argued, that Earth cannot be rotating because this
This is not
gyroscope
about rotation. This is not about rotation.
or tipping.
This is tipping.
Tipping is also a rotation in technical terms. So,
Well,
pardon me,
yeah,
but
you can switch the words around, but it wasn't a bet on rotation.
well, and
So,
I tipped
so
it.
you
If you
admit
want,
if it was a proper gyroscope and not this toy gyroscope, I would be correct.
yeah, if you had bet on a different gyroscope, yeah, but you didn't, and we all told you that other gyroscopes would show the slow rotation or the slow tipping.
Okay, I just want to make that clear. I just want to make that clear. Okay, fine. My mistake. It's my mistake. A man is only good as his word, so no problem. If you're really desperately in need of that money, bro, I'll send it to you. Not a problem. Get me your PO box, and you'll have it.
Excellent. I don't have a PO box, but I will get one. It's definitely worth it. And yes, my projects for Flat Earthers budget is definitely that desperate. I spent a lot of my own money on this stuff.
Okay, but back to the important part though. If the ball doesn't go in a straight path in the inertial frame, That doesn't mean there's no Coriolis effect. It's still there.
The inertial frame, the non-moving frame.
Yeah.
If a ball doesn't go straight in the inertial frame, you think that's a Coriolis?
It could be, yeah. If there's two different paths, if I throw a ball with a little bit of a curve on it and it curves in the inertial frame, yeah, it could be it's still the Coriolis effect. Yes, 100%.
Bro, the whole thing of a Coriolis is that the platform has to be rotating. You got to understand that, bro. If the platform is not rotating, you don't
We're gonna
have a
have it. It's
Coriolis
gonna be
effect.
rotating, dude. It'll be rotating.
Another thing, it has to be traveling in a straight line, right? So you're saying you want the ball to be curving and the floor to be rotating. That's what you're saying.
Yes, pretend we had a merry-go-round and I flew a drone over it from the center to the edge, but I took a little curved of a path with the drone. The Coriolis effect would still be there, right?
See, I'm not sure if that's considered a Coriolis.
The
If the ball is
Coriolis,
curving, because the ball is moving on its own because of the ridges, and the effect on the air. So I don't think that's technically Coriolis effect.
so the Coriolis force would still be there, but it would have been equally and oppositely matched by the thrust force from the drone banking.
There is no Coriolis force. It's
Well,
a visual effect. There's no force there.
Yeah, it's called a pseudo force because it's not really a force.
but if you want to keep this moving drone going in what appears to you to be a straight line, or is a straight line within your rotating reference frame, you do have to apply a real force to counter that pseudo force to keep it going in a straight line in your rotating frame.
No, pseudo forces don't need countering because they're pseudo. They don't exist.
But if you want to cause something to appear or to travel a straight line within your rotating reference frame, you do have to apply a force on it to do so. Right?
If you're on the frame, trying to mix things up, it's not going to work.
Well, let's say you had a turntable that was just had a white piece of paper on it, and you had a marker. The turntable's turning, and the marker is on a track that is straight. And you set the marker at the edge of the turntable, and you push it towards the center while the turntable's turning. Though the marker's in a straight line, it's drawing a curved circle or a curved shape on the surface of that cardboard. Okay. Now, for it to draw a straight line on that rotating piece of cardboard, the track that the marker is on would have to be a curved track for it to draw a straight line. You agree with that? I guess nobody can hear me.
No, we can hear you.
Okay. Do you comprehend what I was saying? You got a turntable with a piece of cardboard on it, and you're gonna have a marker run from, let's say, the outside of the turntable to the center point, and the marker is positioned above the turntable, and it's on a bar, some sort of rail or something. So it can only move in a straight line. If the turntable's turning and the marker, you know, draws a line across that turning surface, it'll be a curved line. But if I want it to be a straight line across that turning surface, I have to have a curved rail for that marker to run on, and it has to be curved in such a way that it's matching the what's happening with the turntable at any given point along its travel. So it's so that it draws a straight line on the.
I kind of get what you're saying.
Yeah.
Not fully, but yeah.
It'd be a hard thing to build. I think you could build it. The pen would have to run on a line that's on a track that's kind of spiral shaped. It would have to move at just the right speed so that it would be drawing a straight line on the cardboard as the cardboard moves underneath it, even though they'd both be moving in a weird circular motion. One would just be a regular rotational motion, but the other would be in a spiral motion. Basically, whatever curve the pen would draw when the pen is on a straight line on the rotating disc, that curve, whatever that curve is the shape the rail would have to be for the pen to draw a straight line on the rotating disc, and it would have to move at the right speed across that rail, that curved rail, to create the straight line. Be kind of a cool thing to show. You could probably do it with a 3D printer, build the mechanism to do it.
I think the Coriolis is a very misunderstood thing from a lot of people.
I agree with that. I think the terminology of inertial reference frame and non-inertial and all that, I think that just throws, wrenches into the works. It makes it difficult for people to comprehend because they don't understand what the word inertial reference frame means. Things like that. I think it's a confusing subject matter because of that.
Yeah, those two words don't help, for sure.
Yeah, they don't. Yeah, it just makes it confusing. And I think flat earthers that are not true flat earthers that just want to argue, they enjoy that one because they know that confuses people. They get a kick out of that because it's as long as you can, as long as you can keep your P's and Q's straight while you're saying it, you can confuse people. So,
See, the thing that confuses a lot of people, even flat earthers, is they think, not all of them, some of them think that it's an actual force, when in reality, it's just a visual effect
it's
demonstrated by the merry-go-round and the straight ball.
The actual force is the inertia that's initially applied to the initial the object that's moving, and also the what's happening to the rotating surface. Those two basically working against each other or for each other, whichever way you want to think about it, create the effect.
Yeah, it's like because it's moving, because the merry-go-round is moving, people might get confused that once you let go of the ball from your hand, it's no longer turning, it's going in a straight line. Like a sling, David and Goliath, the sling
Right.
is turning. Once you let go of the rock, that rock is traveling in a straight trajectory. It ain't curving.
It has
This is
whatever energy was imparted on it on that very last split second before it left your hand. At the moment it left your hand, that's the direction that it's going to head, and that's the trajectory it's going to take. So yeah, it doesn't keep the rotational aspect to it. So it moves in a straight line, but to the people who are on the merry-go-round, it looks like it curved. It looks like
But
it's
let's be clear. Let's be clear, though. Let's say I have a drone and I fly it in a straight line over a merry-go-round and the merry-go-round spinning. Everyone agrees the Coriolis effect is there. You view it from the non-inertial frame, it looks one path. You view it from the inertial frame, it looks like a different path. However, if I had a drone and I fly it in a curved path in the inertial frame, people are saying that that's no longer the Coriolis effect anymore, even though you got two different paths. They can't tell me what effect it is, but they're just saying, no, that's not the Coriolis effect anymore.
Well, on a
Even Jesse
merry-go-round,
almost agreed with it a minute ago,
the
which is wild.
the drone is of on its own. You know, you can if once you leave the merry-go-round, the drone is just like you're flying over regular ground. It doesn't know that there's a merry-go-round underneath it, so to speak. You know,
Yeah, but there's still the
it's
Coriolis effect is there. You didn't address anything I said. There's the Coriolis effect is there, even though the drone didn't go in a straight line.
well the drone. Uh, the drone, if it's programmed to fly in a straight line and it leaves the surface of the
No, I
of
just
a
told you it doesn't
uh,
go in a straight line. We fly it in a curved path. Are you listening to what I say or no?
no, you said initially it was going to fly in a straight line. Then you said it could fly in a curved line. Uh, that was your secondary one. I was still working on the primary one.
Yeah, everyone agrees
All
on
right.
the first one. Everyone agrees on the first one. The Coriolis effect is there on the first one. However, now there's people saying that if you fly the drone in a curved path in the inertial frame, that it's no longer the Coriolis because you need to go in a perfectly straight line in the inertial frame in order for it to be
Well,
Coriolis.
the reason a drone isn't good analogy is because a drone has its own power. These inertial, this Coriolis effect
God.
takes its you get your magic happening because it's leaving the its initial spot and no more energy is being added to it at that point. It's being thrown. So a drone isn't being thrown; it's being powered. So it's a bad
Shit
analogy.
don't even make no fucking sense, man. That makes zero.
Well, there's what's the difference between a ball being thrown on a merry-go-round and a drone being flown over a merry-go-round? The difference is the drone is powered. That's the big difference, right? So that powering, you can make that drone do any damn shape you want, and it's not associated with the merry-go-round anymore, is it? It never really was it? But the ball, when you throw the ball, its initial association with the merry-go-round is at the moment of leaving the person's hand or whatever machine or device. Okay, so and then it has no other force added to it at that point. Now it's just it's dissipating energy. It's not no more energy is
So
being
you're
added to
saying
the
when
system.
drones,
When they're
all
flying,
right,
there's
man.
energy
You're
being
saying when
added to the
drones fly
system
over.
all the time.
All right, we got it, dude. We got it, bro. You're saying when drones fly over merry-go-rounds, there's no Coriolis effect.
Yeah, I think it's a bad analogy. Yes, I would agree with that.
Yeah, when you're saying when drones fly over a
Other
merry-go-round,
than the
there's no
Coriolis
Coriolis
effect
effect.
of the
Holy fucking shit. This is absolutely brilliant. This is genius levels of not physics knowledge.
Okay, let me
well, the
try this,
Coriolis
Jeremy.
effect that would be affecting the drone is the Coriolis effect of the Earth itself, not the merry-go-round. The merry-go-round's out of the picture.
Oh fuck, are we on the merry-go-round again? Jeremy, you need to get off the merry-go-round. Grow up.
Yeah,
Grow up, get off the merry-go-round.
I know. Let's grow up, get off the merry-go-round.
I would
Yeah.
ask Fade. He's absolutely pointless to talk to. You said
Like I said, get off the
drones
merry-go-round.
don't there's no Coriolis effect when you hold on, man. Don't interrupt, dude. You're worthless to debate with or even talk to about any point. This guy's saying drones over merry-go-rounds, there's no Coriolis effect. Earlier, Jesse was saying if things don't go in a straight path, it's not the Coriolis effect, which means the planes wouldn't have any Coriolis effect on Earth. Like, this is brilliant. I just want to let everyone know this is brilliance right now.
No, the point I want to make is that the Coriolis effect that is affecting the drone is not the Coriolis effect from the merry-go-round. That merry-go-round isn't contributing enough of a Coriolis effect to it to be of any substantial interest to you. The one from the Earth spinning would be contributing more to that
Oh,
that
fast you're
drone
spinning the
than
merry-go-round. You're just making shit
the
up, dude. You're just
merry-go-round.
making shit up. Yeah, you're completely just making shit up. I just want to let everyone know. You have no idea how fast the merry-go-round was spinning or anything. The Coriolis effect doesn't
If the
affect the
merry-go-round
thing
is on
flying.
Earth,
There
if
is
the
no effect on
merry-go-round
the
is
thing
on Earth,
flying. The thing
the
just
Earth
flies its
is,
path. And when you view it from the non-inertial frame, that's where you get the effect. The thing has no effect on the thing itself. The Coriolis effect has no effect on the object.
that's right.
That's right.
It's only a person sitting on the merry-go-round gets to see the effect. A person standing away from the merry-go-round doesn't see the effect at all.
Yeah.
The only
All right.
effect the
Good
only
talk,
effect
man.
they would
That's
see is the
great fucking
Coriolis
input.
effect from the Earth itself.
Yeah. Great input.
Okay, let me try this, Jeremy. Your drone that's the ball that's flying in a curved path on the non-inertial reference frame. Yes, it would show a difference between if the frame was non-rotating, right? The curved path would show one path, and if it was rotating, it would show a different path. That's what you're trying to say, right? And you're saying that's still the Coriolis effect, right?
Yeah.
Do I
If you
got you
throw a
right?
curveball, if you throw a curveball off a merry-go-round that's not spinning, there's no inertial frame to even view it from. So there's just one path. There's one path of the ball. However, when you start spinning the merry-go-round, you now have a non-inertial frame. You can get two different paths. Even if you throw a curveball off of the merry-go-round, it's still the Coriolis effect because there's going to be a different path viewed from the non-inertial frame than the actual path it takes in the inertial frame.
Right. Technically, you could be correct, right? But the whole idea is a straight path. But yeah, you're right. It would
No, dude,
show a different. It would show a different path.
bro, they just use that straight line shit because it's an easy fucking example, bro. You know what I'm saying? You still
And
have two different
your
paths.
difference in
You
your
still have two different
analogy,
paths there. Hold on, man. You still have two different paths there. And those two different paths are the one of them from the non-inertial frame is the Coriolis effect. There's no other
and
effect you can think of that would make there be two different paths.
the difference in your analogy is also a drone is under control and a ball being thrown isn't. So
It doesn't matter at all, dude. That makes zero difference. It's irrelevant. Completely irrelevant.
because the drone is powered, you can make it fly in any curved path or straight path you
Yeah,
want.
but you still get the Coriolis effect. You're saying absolutely
You get
irrelevant
the
things. It doesn't
you get the
matter if it's
Coriolis
powered.
effect
It doesn't matter
of
if
the
it's powered or
Earth.
not powered. You're still going to get the Coriolis effect, whether it's powered or not powered. You're saying irrelevant things.
The person on the
This is just
merry-go-round is
annoying.
always
It's
going to
just
see something
wildly
different.
annoying.
The person on the merry-go-round is always going to see something different than the person stationary. That's a given.
There's no question that there would be a different path. So technically, Jeremy's right. Now, I mean, he
How?
is right. There will be a
How?
different path. On sorry.
How is he right?
Well, because if the base is not rotating, the curveball that the pitcher shows will have a certain trajectory, right? It will go this way, and it would appear to go in a certain curve. But if you're rotating, then that curve would change. It'll still be curving the same way, but it would appear to be curving more. You understand what I'm
No,
saying?
no. So it's okay. So usually, okay. Let's say if thrown in a straight line, it'll look. Let's say it'll deviate to the right, right? Now, if he throws a curveball for the person in the spinning reference frame, it's gonna like it's going straight.
Well, it
No
depends
longer,
which
no
way.
longer,
It
no
won't be
longer.
exactly
Yeah,
straight,
yeah.
but
But
yeah.
yeah, but it's because the problem is when you throw it. it looks like all of a sudden some kind of force pushes it to the right somewhere. Let's say if it's spinning towards like the left, from left to right, or whichever, how you spinning around in a circle, anti-clockwise. So if you throw the ball to a person in front of you, and you curve it, it's gonna look straight to that person. So no Coriolis effect from that
Yeah,
person.
Yeah, it
see,
depends. It depends.
elbows
You got
saying
to
that
get
if
it
you don't
just.
go straight, elbows saying if you don't go straight in the inertial frame, there's no Coriolis effect, which I strongly disagree with. It's just wrong.
Because the Coriolis effect is what happens because you think it deviated for no apparent reason.
I know, and if you throw a curveball, we know the real path in the inertial frame will be curving, and it'll deviate from the real path it took. Same thing if you fly a drone slow over the merry-go-round, right? If you fly a drone in a curved line and it looks straight in the non-inertial frame, that's also the Coriolis effect. They just use a straight line as an examples because it's easy, bro. There's no rule that says it has to be in a straight line in the inertial frame. If a
No,
gust of wind happens, let's say I throw a ball in a straight line and a gust of wind happened and blew it off its straight line path in
it's
the
not
inertial
Coriolis.
frame. No Coriolis. That's fucking ridiculous, bro. That don't even make sense.
Yeah, because the wind blew it.
That don't. Yeah, but you still have two different paths, though. This doesn't even make sense, Elbow.
Yeah, a viewer from in each location will see a different path. He's right.
There's two
Because
different
no, the
paths. Like, what are
problem is,
those
is
two different paths
you
called if it's not the Coriolis? What are those two
understand,
different paths
it's
called?
the apparent deviation that happens in the non-inertial frame.
Yeah, so if you threw a ball in a straight line and the wind blew it a little bit and it didn't go in a straight line, and then you have the one path, you'd have the deviation still happening in the non-inertial frame from the real path. It doesn't have to go in a straight line. I'm telling you, bro. That's just the example they use because it's easy.
Right. He's
So it's
correct.
not because it's
When
easy.
he
It's
explains it
because
that way, I'm with you now, Jeremy.
no, it's
I
because
got
there's an apparent deviation because you're throwing it straight,
There's an apparent deviation if you throw it straight or not. There's still going to be an apparent deviation.
not from the spinning reference frame.
Yes, from the spinning reference frame, there will be a deviation from the inertial frame's path. Yes,
Not if you're curving it.
always.
Not if you're curving
Always.
it, bro.
Yes, if you're curving it in the inertial frame, there's going to be a deviation from that curved path on the non-inertial frame. 100%.
Let's see what.
Elbow, think about it. Elbow. Think about if you fly a drone. Say you fly a drone in a curved path over the spinning merry-go-round, right? And the inertial frame, it's curving, and then you can make it go look like it went straight in the non-inertial path.
How fast
You're
is that
telling me that's
merry-go-round
not
spinning?
Coriolis?
Is that merry-go-round spinning once a day, or is it spinning quicker?
Doesn't matter.
Oh,
The
it doesn't
fuck?
Yeah, it
matter.
he's
doesn't
saying
matter.
No, it doesn't fucking matter,
he's
bro. What the
Yeah,
fuck are
it
you
does
talking?
matter. Actually, it does fucking
well.
matter because the
Yeah.
difference between
I
the
think what
You're
he's
difference.
saying
pointless to
is that
talk
you
to,
could
Paige.
find a
Yeah,
speed
yeah, I know,
at
I know.
which
Pointless to speak to.
at
Right,
which
right.
you can fly that it
Go
looks
one
like
at a
it's
time,
straight.
guys. Come on.
Right, right. I know, I know. You can't still can't mathematically show the shorter path through the inertial frame. You can't show that you'd actually save the airline's money. If you could, you'd publish this. You'd be very rich, but you won't do it for some reason.
He can't even follow along. That's not even what we're talking about, dude.
That's exactly
Yeah,
what you're talking about.
We're not even talking
well,
about that, man.
he's not
Follow
You're
talking
along
talking
the
about
about
the
fucking
flying.
airline
convo if
You're
you're
speed.
gonna
you're
get.
talking about a shorter path that would be possible to fly a shorter path.
We're
If
not
that's
talking
possible,
No,
about the shorter path. We're not talking
no,
about the shorter path. Just keep up, dude. Don't jump in and if you're not following the
it is
convo,
the short.
please.
What do you mean? You're talking about Coriolis again. You and your stupid merry-go-round. You need to get off the merry-go-round. Grow up.
Either contribute to the conversation, NASA, or go on mute, bro. One of the two.
Nah, you can't do it, dude. You can't fucking do it. Elbow, I take a curved path in the inertial frame, and it looks like it went straight in the non-inertial frame. You're telling me that's not Coriolis? Elbow.
Give me a second. Check this out. The Coriolis effect occurs everywhere on the merry-go-round for anyone trying to throw a ball or walk in a straight line. Not because it's easy. It's just
It
because
would happen
that
if
is the
it would
the
happen if
effect.
it
Because that's the effect that happens because the
it would
person
happen if
in the
anyone
cor
walked.
it, any the per hold on, the person in the merry-go-round is watching the deviation that the person is going on because they're looking at it and then it's deviating to the right or whichever direction the merry-go-round is spinning.
I realize you would
You're breaking up. You're
in
breaking
a
up.
straight line.
You're breaking up. You're breaking up.
So, Elbow, what do you think of the idea of testing this idea in, or this claim, in a rotating fish tank by launching a small spring
Why?
launched?
He's going to say it's not. He's going to say it's not the Coriolis effect. You got to go in a straight line in the inertial path. That's not going to happen in the fish tank. He's just going to say that's not the Coriolis effect.
So the fish tank experiment won't help him?
There's no point. Scratch the whole fish tank thing, Jesse. Just scratch the whole fish tank because these guys don't even know what the fuck Coriolis effect is. So just forget it.
Oh, so it sounds like he does agree that it will curve in the fish tank compared to the fish tank? Like if we had graph paper along the bottom of the
That
fish
didn't,
tank.
that, didn't, that didn't make no sense. What you said. You just repeated your sentence kind of twice.
Well, let me ask you, Elbow.
You said you
Let's
said that you said that it will rotate on the fish tank instead of the fish tank. What?
All right, so let's say I have a rotating fish tank. It's sitting on a rotating table, and I have a small spring launcher that launches a small projectile from one end of the fish tank to the other end. And I have a camera mounted on the top of the fish tank looking down at the whole scene, and I have graph paper put underneath the fish tank so we can see the actual XY movements of the projectile as it moves along in front of that graph paper. And the fish tank will be spinning when the projectile is launched. Is it your belief that the projectile will follow a straight line along that graph paper under the fish tank? Or do you believe the projectile will follow a curved line against that graph paper?
If the medium, which is the water that's gonna be spinning, is spinning with the fish tank, yeah, it will definitely. If the fish tank would not go in a straight line in the paper.
What about the projectile?
Yeah, that's what I'm saying. The projectile will not go in. I apologize. The projectile will not go in a straight line in the paper.
Okay, and
Just
what
scrap the
effect?
whole fish tank thing. It doesn't even matter. It doesn't even matter because nobody knows what the Coriolis effect is anymore. So none of this even matters.
Okay, and how is that different than the Coriolis
Yeah,
effect, Elbow?
Jesse, question. Why
Hey,
would
Crystal,
you
how's it going?
use a square aquarium instead of a round one, since you're testing the rotation of the Earth and the spin and the Coriolis and
That's
everything?
fucking
You're putting,
absolutely irrelevant.
Wow.
yeah, but those boundaries of that fish tank are squared, and you're doing a circular
Oh my
motion.
god.
So those boundaries are definitely going to influence your whole project.
Buy me one and I'll
Wow.
use
All
it.
right. Yeah, that fucking makes sense. All right.
I'll do it. Just I don't own one, so someone needs to buy me one. But I already own a 2 foot and a 4 foot rectangular glass fish tanks, which were both given to me. So that's why I use those, is because I have them. I'm not made of money. I tried to deposit myself at the bank and they sent me away. But if somebody wants it done with a round aquarium, all they got to do is buy me a round aquarium.
It doesn't matter. That does not influencing or affecting anything. It doesn't even make sense.
So, Elbow, what?
Your rotation doesn't make sense.
Having it happen in a square or a circle fucking fish tank does not make sense for anything. Go ahead, Elbow. Ask Elbow your thing.
Yeah, what force do you reckon causes that projectile to deviate from a straight line right down the center of that rotating fish tank?
It's no force. It's just an apparent effect.
Well,
If
I
you throw it,
disagree. Let's say I put a little capsule of dye inside the projectile, and it leaves a little dye trail as it along its trajectory. That dye is in a physical location in that water volume. It's actually there. It could be detected with a dye detector. Make it a magnetic dye, little tiny magnetic particles that could be detected with a magnetism detector, which is non-visual. It's not a visual effect. The projectile physically deviated from the center line of that tank, right? That's not apparent. That's physical. That's real. It actually deviated physically, dimensionally, geometrically. It deviated from the center line of the fish tank, right?
if the medium is rotating with the water, with the rotating reference space, you don't have. It's gonna follow everything that's in it. Is gonna follow the curve. So you're never leaving the reference frame.
Wait, so the projectile would, if I launched it center of the tank, pointing straight at the other end of the center of the tank,
Are
just
you
like
talking about
imagine.
centrifugal? Are you talking about centrifugal forces?
I'm just talking about an experiment here, where I have a rotating fish tank and I launch a projectile from the center at one end straight along the center to the other end. Will rotating it make it deviate from that path along that trajectory along the center of the tank?
It depends on the speed. Initially, it'll follow a straight line, but then when it slows down, it'll match the water because
Well,
it's a
obvi-
rotating. Yeah.
obviously it has to be moving for the thing to work. Yeah.
Yeah. So you ain't proving nothing there. Like
Well,
Elbow said, centrifugal force.
but if the tank is centered on the rotating table and the projectile is going down the center along the center of the tank, parallel to the length of the tank, then centrifugal force is not going to steer it one way or the other. It would just go straight, right? Unless
If you launch it with
Coriolis.
enough speed, yeah. But eventually, when it slows down, like if you had a large enough fish tank, it wouldn't continue going straight.
Well, it's only 4 feet. I think I can get if I make a little kind of fluid dynamically efficient torpedo dud, just a little blank, just a little projectile that's shaped correctly to move through the water without a lot of drag. I think I can get it to go from one end of the tank to the other, which is only 4 feet on the big tank, and about 20 inches if I use the short tank.
Okay, so I don't know. I don't know. There's no point. You just scrap the fish tank thing for me. Like if somebody else wants you to do it, you want to do it for them, that's fine. But as far as I'm concerned, it's fucking pointless. So don't even bother.
Yeah, I'm not sure. It sounded like at first Elbow said it would curve relative to the bottom of the fish tank, and then it seemed like later he said it wouldn't. So I'm confused what his position is.
Just right out the gate, you can't even do it because you need to make it go straight in the inertial frame. And that's not going to happen if you shoot a torpedo out in the water while it's rotating.
Yeah, you
It's not
don't
going to go
have
straight in
an
the
inertial.
inertial frame. So they're not, you do have an inertial frame. It's what's not rotating, but you're not going to get it to go in a straight line path. So I wouldn't even bother because they're just going to come back and be like, oh, it's curving in the inertial path. That's not the Coriolis effect.
Jeremy, in the tank, it's always rotating. There is no non-inert. It's all non-inertial. I mean, yeah, that's right. It's always
It's
rotating.
not right.
You don't have a non-rotating situation in the fish tank, like Elbow
Right.
told you.
But you could view it from above the fish tank. You could view it from an inertial frame. You could view it from an inertial frame.
View it, yes, but it's not actually. It's always in a non-inertial frame. It's always in a
No,
rotating frame.
it goes inertial as soon as you change your tangential speed to the rotation. That's when you go inertial. Doesn't matter if there's a medium, no medium, medium's rotating with the thing, medium's rotating faster than the thing. It doesn't even matter.
Remember when we said it's a visual effect, Jeremy?
Yep. So here it is. By throwing the ball with the exact amount of spin needed to counteract the Coriolis flexion, both effects neutralize each other from the writer's perspective.
That's what I said. The real force created by the Magnus effect, if it
Yep.
matches the fictitious force, then they cancel each other out.
So no Coriolis
All
effect.
right. So you guys are saying, okay, cool. So you guys are saying if I throw a curveball over a merry-go-round, however far the path is on the merry-go-round, that's how far the ball went, right? That's what you guys are telling me? Just to be clear? Because there's no Coriolis effect, right? So these are all real paths now the ball's taking. You guys are cool with that?
On an inertial frame. Is that what you're saying?
Everywhere, yeah. There's no
Viewed
Coriolis
from.
effect. So there's no Coriolis effect. So any path, if I'm on the non-inertial frame, there's no Coriolis effect, right, Elbow? So that's the real path that it went, right? Because I'm about to blow this whole fucking idea out of the water in like 5 seconds.
Oh, you're wrong.
Again,
On a non-inertial frame, nothing is as it seems. It's on the inertial frame that
Yeah,
you actually
Elbow.
see the path.
I know, bro. Elbow,
yep.
there's no Coriolis effect. So whatever path from the non-inertial frame, that's the path it actually traveled, right?
Where does the Coriolis effect happen?
I'm just asking you, since there's no Coriolis effect here, when I view this from the non-inertial frame, that's the actual path that the thing went, right? This is about to
Again,
get bodied very
do
quickly,
you
bro.
understand where the Coriolis effect happens, right?
Yes, it happens when viewing motion from a non-inertial reference frame. I understand where it happens. Yes.
Okay, so if you cancel out the with the curve, you cancel out uh, uh the inertial reference frame and the Magnus effect. Then you definitely don't have a Coriolis effect because it's an
I hear
apparent
you.
deviation from the
I heard
rotating reference
that.
frame.
I heard that. Now let's get more into it. So you're saying that if I don't go straight in the inertial frame, that there's no Coriolis effect, meaning whatever I see from the non-inertial frame, that's the real path that object took, right? Elbow.
That okay? Say that one more time.
Since there's no Coriolis effect here, if I don't go straight in the inertial frame, like let's say I had a ball and I curved it or whatever, just anything not going straight, anything curving a little bit, and viewed from the non-inertial reference frame, obviously since there's no Coriolis here, that's the real path it took, right? as viewed from the
From the
non-inertial
outside
reference,
perspective.
as viewed from the spinning as viewed from the non-inertial reference frame. That's the real path, right?
I'm not saying that because the path
Well,
is
why would it? Why
you can
wouldn't
only
it?
see the actual path from the outside
Well, why? What do you mean? Then why is there a different path? What's going on? That there's a different
because
path?
you're spinning it and therefore is canceling out the Coriolis effect of the apparent deviation.
You can't cancel out the Coriolis effect. Like that's not a thing you can cancel.
Yes, you
Like there's
can, bro. What
okay.
are you
So you're
talking
telling
about?
me
Because it's an apparent deflection, not an
okay.
actual
All right, bro.
deflection.
All right. So if I make something go a curved path over a non-inertial reference frame, is that the real path or is that not the real path when viewed from the non-inertial reference frame? Hello. You're on a merry-go-round spinning around. I throw a curveball over you. You trace it out on the ground of the merry-go-round where the ball went. Is that the real path or is that not the real path?
Give me a second. My daughter's calling me.
Like thinking that something has to go straight in the inertial frame or it's not Coriolis effect is fucking crazy. It's crazy. You tell me I can't fly a drone in a curved path over a spinning merry-go-round and all of a sudden there's no Coriolis effect? Cancel it, Jesse. You're going to view it. Jesse, do you think it's going to go straight in the inertial frame? This little torpedo thing you shoot out?
Not perfectly. It won't go straight in either of them
I
because
know. That's what I said. That's why I'm saying cancel it because they're just going to say it's not the Coriolis effect, which is fucking crazy.
yeah, because the if I did it with air in the fish tank, then it would go um, extremely close to straight in the inertial frame. But with water is so viscous and so massive, it's going to have some influence and it's going to cause it to deviate some from straight in the inertial frame. So it won't be straight in either frame if I'm using a super viscous media like water. Although why couldn't I use air as long as
Can you
the
just because they want the medium rotating with the thing? Oh, here's what you could do, Jesse.
well air
Instead of
if
the
I
projectile, hold on. Instead of the projectile, have a you could have a ruler or a string or something in the non in the inertial frame. So it wouldn't be rotating. You could have a ruler, and then you could take a waterproof marker, put your hand in the center of the fish tank at the axis of rotation, have your hand right there, and then follow the ruler that's not spinning. Follow the ruler straight out, and then it would be going straight. And then you'd have it. No, what do you
I'm
think
back.
about that one, Elbow?
I'm
you
back.
lost me.
Yeah, what's up? Say it again. What would you ask me first?
Just hold on. If we get a fish tank with the spinning water, and instead of shooting something out, right? We just hit we have a ruler that's not spinning that goes from the center to the edge, like above it, above the fish tank. And Jesse has a waterproof marker, and he's got his hand inside the fish tank at the center, and then he just moves his hand in a straight line out towards the edge. Is that the Coriolis effect? He's in the water. His hands in the water. His hands in the water.
But he's in the outside, right?
No, his hands in the water.
Is it rotating?
Yes, you have your hand in the center of it. You're reaching in. You're reaching inside with your hand. Your hand's inside the water in the middle of the fish tank with a waterproof marker about to draw on the bottom of the fish tank. And he has his hand in the fish tank. It's in there, and then he moves his hand straight out. He follows the ruler that's not spinning. He follows it straight out to the edge. Is that the Coriolis effect? His hand went
Because
straight, right?
no, because he's actually freaking doing that. He's making it go straight by himself.
Yeah, he's going straight in the not in the
Yeah,
inertial
he's in
frame.
other words, he has power over where the his fingers going.
So this is about powered flight. The thing grenade was, bro. I give up. Just forget it, Jesse.
What do
Forget it,
dude?
bro. I don't know. I don't know what to tell you. Like you get two different frames there. There's two different paths. Just because if something curves or doesn't curve in the inertial frame doesn't mean it's not Coriolis all of a sudden. That's crazy, bro. Just forget it, Jesse.
Well, okay. But what if instead of using water, I used air, but I covered the fish tank and sealed the top up completely and had a window in the top so that the air was rotating inside the fish tank with the fish tank? I could even have a burning candle inside there to illustrate that there was no draft.
There you go. What about that one, Elbow? Sealed fish tank. The air inside the fish tank's rotating with the fish tank now.
I like to see that.
Well, bro, it's like your car. When you drive your car down the highway, the air is moving fucking with your car. You know what I'm saying? Go ahead, do it with the air, Jesse. Do it with the air, then you can get it to go straight in the inertial frame.
Yes, definitely.
Yeah, yeah, of course. Go ahead, do it up. Does that good? Does that work now, Elbow? We get it to go straight in the inertial frame. That which doesn't even make sense, but you get to go straight in the inertial frame. Bam, Coriolis, the mediums spinning with the ground, right? All that it's all good. This would prove this whole idea wrong that you can't have it when the medium's spinning with the ground. Or no? Elbow.
Yeah, well, let's see it happen.
But that would do it. That would do it for you, right? If with all this whole scenario is good, like that, it all checks out. There you go. I don't know. Do it up, Jesse. See what they say. Is that easy or no? Can you do that today?
Not today. I've got work I got to get done today.
No, because you can get a neutrally buoyant and a buoyant one. But what do you want to do? Oh yeah.
Good question.
Which one's going to be less controversial? Can we just do it back to back 2 times with both of them, Jesse? Can you fire up the balloon one, do it, and then fire up the other one with the flames, tea light candles. Grab your mom scented candle, whatever you got.
My mom quit sending candles about 10 years ago
Cold turkey.
when she died.
Oh, so sorry.
Not really.
It's cold turkey.
Yep.
Uh, but can you do it with both or what? Like back to back?
I mean, there's an infinite number of things I could do.
Yeah, I
But
mean
like,
those are easy though, right?
why don't we pick one that is the best? Frankly, I think the flame is the best
The
because
flames will be easier.
they're super, super sensitive to draft. Everybody knows how. Nobody here doesn't know how to run a candle. Okay,
You should
and
use the candles. You're right. You're right. You go with that elbow. We'll do the candles.
and balloons, like, they're gonna like static. Even if we try to get them just right to neutral buoyancy, they're gonna like stick to the ceiling or the wall,
Like
or
you're gonna be
they'll
elbow. You're
lose a
gonna
little bit of helium and then they'll just sink. And yeah, the candle flame, if the goal is to detect breeze or movement of air relative to the tank, the candle flame is the best way to go.
yeah. You understand elbow. Yeah, we'll use the flames, Jesse. That's a good point. You understand elbow that if the air in the tank wasn't moving with the fish tank, the candles would be like flickering and wavering. You know what a candle looks like when you move it around, right? If the air is not, if there's any wind or you're moving a candle, you know what I'm saying? If the air is not steady with the candle, you know what happens. So I think the candles is a good one. You good with that, elbow?
So why don't you want to do it with the water again anymore?
Because you can't get it to go straight. Because the medium's gonna
Exactly. Because what? The
because the
medium's gonna
medium's
drag it along with it.
yeah, but you're still gonna have Coriolis. Just because you don't know how Coriolis works doesn't mean it's not there.
It's not that I don't know how Coriolis work. It's just that you understand that there, if the medium is moving with, it cancels out the Coriolis
Okay, and we'll
because
be
there's
able to
not
see that,
there's.
and we'll be able to see that with the candles in the fish tank with the thing, right?
Yeah, I don't know. Maybe.
What you mean? If we do it, like, does this all sound good though? If the candles aren't flickering crazy and the thing's spinning and we got both the frames,
I
like
mean, you're running away from the water though. The thicker medium.
Well, instead of water,
yeah, because you don't understand. Go ahead, Jesse.
why don't we use blackstrap molasses instead of water?
Oh, because you're not going to get it to go straight in the inertial frame, Jesse. We just went through this. He thinks the mass Coriolis magically disappears if the thing doesn't go straight in the inertial reference frame. It's fucking crazy, bro. It's actually crazy, Alba. I'm so mad at you right now.
Your
Again,
AI
you're
gets
not
serious with you, man.
understanding that. You guys are not understanding. In the fish tank, it's always a non-inertial reference frame. You guys are not getting that for some reason.
Yes, and then if you're viewing it from above where you're not spinning, you're viewing it from an inertial reference frame.
Viewing it,
Yeah,
but
that's
the
all you do with the
projectile.
Coriolis effect. Whenever there's a Coriolis effect, you're only viewing things. That's all there is. This is a viewing thing. Why
Yeah,
would you
but
say
Jeremy.
viewing it like that means something? Why would you say viewing it like it meant something? Obviously,
I
we're
guess
viewing it.
you're.
It's the Coriolis effect.
Yeah, but it's always in a non-inertial reference frame in the fish tank. You know,
No,
that's what you're not getting.
no, that's not true. As soon as it changes its tangential speed to the non-inertial reference frame, then it's now gone inertial. That's what you're not understanding. You're just wrong.
Okay.
You're just wrong on that. And it can never go inertial because it's in a non-inertial medium. Like that doesn't matter when you change. If the thing changes its tangential speed to the medium or the ground or whatever's rotating, you just went inertial.
When we do the merry-go-round thing, right? When we explain what Coriolis is, you have the rotating frame, which is the merry-go-round, and where the ball travels, that's in the that's in the inertial reference frame, right? Right, Jeremy?
It's in both. No, it's in both. No, that's not right. It's in both. There's that point exists in both frames.
Then you're not getting it.
Yeah,
You're
because
not
in
getting the
these are not
Coriolis.
inertial reference frame that goes into inertial.
The whole thing is that the rotating merry-go-round is the non-inertial, and the air above it is supposed to be the inertial. That's what you're not
No,
getting.
no, you
Yeah.
go inertial. You go inertial when you change your speed. You change your tangential speed to the non-inertial frame. That's when you've gone inertial.
So you're not getting it, bro.
No, you're not getting it. You go inertial when you change your speed to the non-inertial frame. That's when you go inertial. You're not getting it.
Well, one of us is not getting it. So how is the ball traveling straight in an inertial reference frame, which is the air above the non-inertial reference frame?
What's the question?
How is the ball traveling straight if you think it's in a non-inertial reference frame?
It's not in a non. Well, it depends on where. If you're looking at the ball from the non-inertial reference frame, the ball's that's the frame. What's the question? I don't
You're
understand
saying
your
it's,
question.
you said that the ball is it's also in a non-inertial reference frame when it leaves the person's hand. Isn't that what you said?
No, when it's flying, it's in the inertial reference frame. When as soon as the ball changes its velocity to the non-inertial reference frame, it's now inertial. It doesn't matter if the medium's rotating or not.
So that's where you have the misunderstanding.
It's not a misunderstanding. That's how you get. That's how the Coriolis effect happens. That's how you know you've
No,
gotten the Coriolis effect.
no, there is no such thing as the Coriolis. It's a visual effect. And if you're in the water that's turning, you don't have a non-inertial, I mean, you don't have an inertial reference frame because the tank is turning, making it
You
non-inertial.
No, you 100% do have an inertial reference frame. You can view it from above where it's not rotating, or all you have to do is view it from anywhere where you've now changed your tangential speed to the non-inertial reference frame. So there is definitely an inertial reference frame there.
In the spinning tank.
Yep, in the spinning tank, there's an as soon as you change your tangential speed to the rotation, you've gone inertial. That is literally how it works.
That's not how it works, man.
So you're telling me I changed my speed, tangential speed to the non-inertial reference frame, and I'm still in the non-inertial reference frame? That doesn't even make sense, dude. This is gibberish.
And you're not getting it. You're in a non-inertial reference frame. No matter what you do, you're still in that rotating reference frame. This is what you're not getting.
Yes, and yeah, you're in the non-inertial reference frame, and then you change your tangential speed to that non-inertial reference frame. You guys are telling me you're not inertial, you're not in the inertial frame now? That's ridiculous.
No, you're still in the fish tank.
You're in the non-inertial reference frame now. You've changed your tangential speed to the rotation, dude. You don't know how this works, bro. Nobody knows how Coriolis works. Very few people here know how this works.
All right. All right. So you think in a merry-go-round that the air is still turning with the merry-go-round? Is that what you're trying to say?
I've never said that. It's obviously
So
not.
how is it then? So how is it then that you're not understanding this? The whole idea of the merry-go-round is it's non-inertial, and the air above it, right? The one that you throw the ball in is the inertial one. So where is that in the tank? You would have to
Jesse,
throw the
cancel
ball,
it.
the projectile above the tank, bro. You're not getting it.
Jesse, cancel the fish tank shit. Cancel all the fish tank shit, Jesse. Let these guys die stupid.
Well, one of us is stupid. What is that? Anybody else? Anybody else care to comment on this? This thing confuses a lot of people.
Well, I would say it's being presented confusing. But yeah, Earth's not spinning. There is no Coriolis effect. End of story, right?
I would agree with that, but what's your take on the non-inertial and the inertial reference frame? Can you have a non-inertial reference frame in a spinning tank? What's your opinion on that? In a spinning tank full of water, while your projectile is thrown in the spinning water, can you have an inertial reference frame there?
Well, am I observing this, or am I in the tank? Am I the stick? What is the true reference frame? My reference frame, or the what's happening in the tank? Like assigning a reference frame in the tank for what's happening in the tank and being the observer are two different things, right? Or am I taking this too far? I'm trying to get at what this inertial, non-inertial reference frame is going to tell me in the long run. Am I the observer, or what's happening in these places?
Well, what's actually happening? What's actually happening? Can you have an inertial reference frame from a projectile that's thrown in the water that's rotating?
Yeah, I would say that, yeah, if you're in the tank, that's what you're assigning the inertial reference frame from, right? Yeah.
Well, this observation is done from outside the tank, right?
Well, then
I mean, no one's in the tank.
then your reference frame would be non-inertial, right? Well,
Outside the tank.
unless
That's what
it's
I'm trying to explain to Jeremy. Yeah.
yeah,
The iner-
like you would have to be in the tank spinning with the water in the stick, right?
I would imagine so, yeah. But even then, let's say you're in the tank, right? And you're observing it. Is there a non-inertial reference frame in the tank? Because the whole thing is spinning. So it's non-inertial. The whole thing is non-inertial. Can you have an inertial reference frame in the tank?
Yeah, but when you have that, even that merry-go-round, when you are at that center of that merry-go-round, that rotation is very slow, depending the further you go out of that merry-go-round about. So in a way, that point of inertia in that rotating frame is just the center point from the bottom up.
Right.
So you're saying the center point is inertial.
That's the
None of that
only
shit makes
point of
sense, bro.
rest.
Yeah, but
Then we
don't
got
forget, they want to throw a projectile, right, in the tank. So the center point doesn't play a role here.
Yeah, it could if you fire that bullet from the top from the bottom to the top to its center axis.
Vertically, you're saying. But that's not what they're. I get what you're saying, but that's not what they're trying to do here.
So isn't the idea that you can't measure the effect of the movement of the Earth while you're on the Earth? Isn't it that simple? You can't detect any motion while you're on it.
Well, that depends because they say that the ballers say that the Atmos is spinning with the Earth, right?
Ah, yes, yes.
So yeah, that's another caveat that you got to take into consideration.
Yeah, but if the Atmos is spinning with the Earth, so the water should be spinning with the Earth, and they don't.
Yeah, then you would have no effect there. Exactly. That's what it boils down to. First of all, they have to prove that the Earth is spinning in order for this so-called visual effect to happen. That's why a lot of people get confused with this because there is no effect. It's visual. There's no force here. It's a visual effect. One rotate.
Yes, because
You're on a rotating frame, and you throw a ball in a non-rotating frame. The ball goes straight, but it appears to the people on the rotating frame that it's curving. It's that simple.
yeah, but that's because the people's angle to that ball is changing.
Right. Exactly. You're the one that's changing, not the ball. The ball is traveling in a straight line. Hence, it's a visual effect. I mean, all you got to do is think of it, the actual wording of what it is, and it's quite simple. There is no effect. It's just a visual thing. There's nothing curving. The only thing moving is you on the rotating reference frame and making the straight ball appear to be curving. It's that simple.
I agree. And you're saying a lot of people are trying to come in here and say, yeah, Coriolis effect is working, like it's actually proving something, and then they get into this reference frame stuff.
Exactly. Yeah, they want to do a test in a fish bowl filled with water, which by definition is rotating. I mean, it's, how simple is that? You're in a rotating reference frame.
And then you change your tangential speed to the rotating reference frame. You now have the Coriolis effect, regardless if you go straight or in a curved path. Like, it's not hard, bro. That's how you get the Coriolis effect. You change your tangential speed. You now got two different paths. It doesn't matter if it's a curved path or a straight line path in the inertial frame. You got the Coriolis effect, dude. There's going to be two different paths. What other thing would give you two different paths? Let me ask you that. If it's not the Coriolis effect, how else do you get two different paths?
In what?
What other thing would give you two different paths? Just answer that, please. I'd love to know.
I don't know what you're talking. Be more specific. What do you mean? What other thing?
We know the Coriolis effect gives you two different paths, right?
Yeah, because there's a rotating reference frame that you're on.
Yep. Yes.
It's
So we know the Coriolis effect gives you two different paths. Yes. So what else would give you two different paths if not the Coriolis effect?
I don't understand the question. There is no other thing unless you
And
move,
this,
unless a plane turns, unless you turn by
when you have
yourself.
the
There's
core,
no other. I don't
when you have the
understand. Does
Coriolis,
anybody understand the question
I'm going to
here?
explain it to you. And the Coriolis effect in the inertial frame, it looks like it goes straight. In the non-inertial frame, it looks like it's curving. Two different paths. The Coriolis effect gives you that. What else would give you that if not
No,
the
there is no
Coriolis
two
effect?
different paths, bro. There's one path only.
Oh my
The
God.
ball travels in one path. There is no two
Okay.
different paths.
Okay, but it looks like it went straight in one. I said it looks like it went straight in at one, and it looks like it turns in the other frame. Looks like.
Looks
Okay.
like. That's right. A visual
Yeah.
effect.
Correct.
Okay, we have this visual effect that happens where we get two different paths, looks like two different paths. What else would give you that if not the Coriolis effect?
Nothing. Well, what do you mean?
Exactly. So now if we know if we have two different paths, we know we
You
have the
don't have two
Coriolis
different
effect,
paths.
right?
You don't have to. You're double speaking, bro.
We
You
that
don't have two
if it
different
looks
paths.
like it has we know if it looks like it has two different paths, we know we have the Coriolis effect, right? Do I have to say looks like every time for you to not freak out?
Bro, I'm
Yeah,
not
word means
freaking out.
things.
You're,
Words mean things, bro.
yeah.
Okay, I rephrased it correctly. So now we know if it looks like it has two different paths, we know we have the Coriolis effect, right?
Okay.
Is that true, Elbow?
It's not an effect. Let's get
Hold
that
on,
straight,
bro.
right?
Hold on, man.
Yeah.
Elbow, is that true? Two different. If we looks like we have two different paths, I gotta put looks like in front of there every time, or else he's gonna fucking lose it. If it looks like it has two different paths, we know we had the Coriolis effect,
No,
right?
this is not. Oh, jeez, the Coriolis effect is the apparent deviation from from the non-inertial reference frame.
I know. Two different
So
paths. Looks
so
like. Looks like two different paths.
no,
Yes.
not looks like two different paths. It's an apparent deviation. In other words, it appears it deviated from where the path you threw it to.
Yes. So you have one path in one frame. It looks like one path in one frame, and then it looks like a different path in a different frame. If we have that, we know we have the
You're
Coriolis effect, right?
trying to make it seem like, oh, because it has two different paths, therefore that's Coriolis. No, bro, it's the apparent deviation
Yes, the apparent deviation makes there be
from
two
the
different
reference
paths.
frame, from the
The apparent deviation makes there
non
be two different paths, dude.
from the non-inertial reference frame. It's the apparent deviation from the non-inertial reference frame, which is Coriolis.
All right.
Bro, I thought I explained this to you 3 years ago and you got it, but
You
it
just
appears
agreed
you
with me.
still
You just agreed with me, and
still
Elbow's disagreeing with us now. So I don't know what you're
No,
getting all excited about. SC just agreed with me on the thing you
yeah, but
disagreed with
he
me
doesn't
about,
understand
Elbows.
that you're
So
trying to make the claim it's because it's two different paths. Therefore, that's Coriolis.
looks like two different paths.
It's
Looks like.
again
Did I do a good job,
the
SC?
Coriolis effect. The Coriolis effect is the apparent deviation in the inertial reference frame. Even though in the inertial reference frames you can see that it's going straight.
Yes, apparent deviation looks like two different paths. Yes.
No, it doesn't look like two different paths. It
So
looks
the
like it
apparent
deviates.
deviation looks like the same path.
No, it looks like it deviates.
It looks like it, yeah, different path,
It,
from a path, deviates from a path, right?
no, the
Come on, bro.
path
Why
is
are you
always the
playing
same,
fucking word
Jeremy.
games?
That's
Why are
what
you
you're
playing
not.
word games with me, Elbow? You're pissing me off, dude. You're fucking pissing me off.
Somebody
All right,
needs to do a bong, I think.
I'm fucking doing it right now, and it's not helping.
Because you're not getting it, bro. You're not getting it. This is a mind perplexing thing if you don't think of it as what it is, right? It's a visual effect, bro. The path of the ball never changes, bro. It's only because you're on a rotating reference frame that it appears to do that. It's that simple. Yes, it's an optical illusion, like Rakia just typed. Exactly. It's not real. The ball is not curving, it's traveling in a straight path. It appears to you because you're the one that's moving. I mean, it's that simple, man. That's why they call it a pseudo force, a non force. It's not a force, it's an illusion, it's an optical effect.
I mean, this is like basically the same thing as I'm turning in circles really fast, and I keep going faster and faster, and everything looks like it's spinning, right?
Exactly. Something like that. But you're the one that's spinning.
But when I was stopped, it didn't look like it was spinning. But now I'm moving, so it looks like it's spinning, right?
Yeah, kind of like that. Yeah.
And because I'm spinning, it looks like it's spinning. Therefore, Coriolis. Is that the conclusion?
Yes, if anything, if you view anything change its coordinates according to the non-inertial reference frame, you use the Coriolis effect is there. Yes. It's just a looks like. It's an optical thing, basically. There's a real path in the inertial frame. That's the real path. And then you have the path in the non-inertial frame, which is not a real path at all. It's not even close because you could get on a merry-go-round, spin under a jumbo jet carrying passengers. That jumbo jet's going in a straight line, give or take. And it looks like it's doing, spirals in the sky to you or corkscrews or whatever it looks like. But we know it's not actually doing that, not even fucking close, it physically can't even do that. It's impossible.
Reminds me of how lazy NASA is with their live streams, and they're up in orbit or whatever, and they can't make the Earth rotate. They can't make the clouds move. It's still shot the whole time. Like, where are all these other motions?
This thing has been confusing both ballers and flat earthers for years, yet it's such a simple concept. It's kind of mind boggling, really.
I think the globe has such few points that they get creative in discussing the points that they do have, right?
It's the dogma, bro. They follow the dogma, and it, it's kind of it's like a mind meld, like the Vulcan mind meld.
Bro, the shit's not hard, dude. If you view motion from a non-inertial reference frame, you have the Coriolis effect. It's super simple. It's not like difficult as people are like making it seem or whatever. It's that
Yeah, I
simple.
know. It's an optical illusion. It always was.
Sounds like a. So, where does the Coriolis effect happen? It doesn't.
It
I
happens on
remember
the
my mom saying,
non-inertial reference frame when you view it. It happens when you view motion from a non-inertial reference frame. That's all you need. If any motion happens according to the non-inertial reference frame and you're viewing it from the non-inertial reference frame, you have the Coriolis effect.
Say that one more time.
If you view motion from a
You view
non-inertial
motion?
reference, yeah,
No,
motion
that's
according
way
to the
too
non-inertial,
ambiguous.
it's not. It's
It
not. You have
is
the Coriolis
motion.
effect.
What do you mean if you
Any
view
motion.
motion from non-inertial reference frame? What?
You know what? That actually might be bad because you can have that thing they say happens at the equator, so the Globers aren't going to buy that.
Take a swing at it.
They still say the Upvost effect is Coriolis though, but I don't know. Whatever, dude. Whatever, bro.
if you're on a merry-go-round, right? Somebody like Jeremy spins the merry-go-round, you're standing on it, and a bird flies overhead while you're looking up. There's your effect.
You have to change your tangential speed. See, that's the way to phrase it, because then it works with the equator on a globe, and all the globers would have to agree with this. When you change your tangential speed according to the non-inertial reference frame, you get the Coriolis effect. That's all you need to happen. If you make that happen, you have the Coriolis effect. That's why they get away with it. Oh, it still doesn't work on the equator for them. I don't know. Whatever. I don't care, bro. I don't even fucking care. You guys are pissing me off today.
I don't understand how you guys think that for thousands of years they've kept this secret from everybody with tools and instruments, and it's all fake.
Well, yeah, think of it like this, NASA. Why was the revolution in America fought?
It was about money. What are you talking about?
Well, no, it's about people's independence from a
No,
system that they didn't want anymore, right?
We're
it
getting
was all
taxed with no taxation without representation.
Right.
it was all
People
about money.
realized people thought to themselves, "We're getting bamboozled." At least this is the story, right? Like we're getting bamboozled, so we're getting taxed 3% or whatever it was. The king raised the tax on it, and they were like, "Fuck that." Not today, Satan. You know what I mean? Like there was like a cabal of people that were benefiting off these the colony, and they didn't want to partake in that like cabal that was financially benefiting off of their suffering. You know what I mean? Right?
If you look into the Revolutionary War, it wasn't this great march to freedom like we were taught in elementary school. It's like
So you're
30
saying,
people.
hold on. So basically, what you're saying is that someone's lying about what we were taught in elementary school about
No,
the
it's
fucking
just
the revolution.
it's just a way it was taught. You know,
Right. So we could agree that there is fucking like a secret agenda.
There's
Like,
no
why would
secret
they? Why
agenda
would they not? Okay. So why did they teach us what I just said?
because it's easier. It's easier to
Right. It's easier to fucking lie to someone than to tell them the truth, too. Right.
easier to lie. Well, I mean, you should
Depends on
know.
what it is.
No, I'm just saying, if they're going to lie about the American Revolution and George Washington never telling a lie about the apple tree, then what else would they lie about? If that's not even what it's really about, like, you said, right? All I'm saying is that there, I mean, even pursuant to your own logic about this matter, there are conspiracies.
No one called.
Well, I
No
mean,
one
just because
called
it's
it a
easier to tell someone
conspiracy.
that shit, right? It's just easier to tell them that.
It's sort of like one-sided education. Sort of like survivor bias. Everyone thinks that.
Well, that's how we filled out the Cosmos, dude. You guys bought the cookie cutter version, and we're trying to say, wait a minute, it's more
Well, no, no,
complex. And you guys are like, no, George
no, no,
Washington never
no,
killed
no, no. It's
Daniel.
the other way around. It's the other way around. You're going back to the version. You're going back to the version that was kicked out 2,000 years ago.
No, we're
Because
fucking no. We're taking the explanation that you've swallowed hook, line, and sinker
so, where's
because
the
it's
evidence?
more complicated than that.
Where's the evidence?
The fact that we're here, dude.
Well, the fact that we're here is it's more about you know
No, it's more
lack of
about people who
education.
decided that they trust their senses over the idea that, like, well, if you're on a train with a tennis ball, you know what I mean? Like, you wouldn't even know you're moving. Well, like, we just
Correct.
fucking look at it like, no, 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 I'm not moving. And that makes more fucking sense than me being on some fictional fucking spinning fucking, bullshit, dude.
Well, again, if you
Well, I'm just saying, like, I mean, for the average person who doesn't know any better, just fucking tell them about trains and tennis balls. They'll buy that shit. But it's more complicated than that, just like the Revolutionary War, right?
Paid, paid. Do you believe in Helios? Are you going to the Revolutionary War? Or are we going on a movie?
No, I'm just making my
I don't
case
even
of like,
know. I was about
things
to
are more
start arguing
complicated.
with paid.
Things are more complicated than it seems. Go on, bro.
but the yeah,
It's
but you're
not
going
worth.
back to this. You're going
I
back to
changed
the
my mind.
simple version.
Yeah, you're too simple. You don't know how fucking peanut butter works. Peanut butter sandwich. You don't know how bread works. What was it?
Yeah, you don't know how bread works.
Fuck out of here,
I
simple
was
jackass
crying. I was
motherfucker.
crying. I think when you first said that, I was crying laughing. That was so funny. Bread works. Or like
Hey,
you're lying about bread. You know, even worse.
it's a fucking conspiracy. The whole bread thing's a conspiracy. With the spraying shit on the bread, the GMOs,
Dude, the
gluten,
goose feathers. You know about that?
the what?
It's a chemical called L-cysteine or something like that. And if you see it, it's basically duck feathers. And they put it in the bread. Why? God knows why. You know what I mean? Look it up. Dude. It's L dash like it's CIESTINE or some shit. Still L-cysteine. It's in bread. It's like fucking duck feathers and shit.
Hey yo, NASA. So NASA. So you don't believe in like no conspiracies like at all, or are you just talking about like Illuminati type shit?
Well, I think he just said, I mean, NASA show there are conspiracies, especially in the education system. Quoted 2026. I think he just said, specifically in the
I
education
wouldn't call
system
that
with the
conspiracy.
Revolutionary War, they're lying to
Write
us.
that shit down.
I wouldn't call that a conspiracy though. I'm sorry. It was just
They're not
Oh, oh,
conspiring to teach us lies in school.
no. They're just teaching one side.
But no, it's just easier, like you said.
they're
That
just
was
lying.
it was
It's
just
just like
it's
one
easier.
person
It's
on
easier
their
to
own.
tell someone. Well, like it's like the idea of like I mean, my romantic take on the American Revolution and the idea of whatever that like people were trying to fight a conspiracy in the sense that they were being ruled over. So there's evidence of a conspiracy, and then you were saying nah because that's not what really happened, which is proof that there's more of a conspiracy even.
No, I wouldn't call that a conspiracy. I'd call that one-sided education, if you will.
Just so just one guy lying. That's all that is. Because if you got more guys, then it's a conspiracy,
Well,
right?
I
So
mean,
is it
dude, if
multiple guys? Hold on, Issa. Is it one
they couldn't
guy
even hide a
lying?
blowjob in the White House, dude.
Is
I
it hold
wouldn't.
on, Paid? Is it just one guy lying that's
You
teaching all
see,
this stuff, or is it like a multiple
I wouldn't
thing
call it.
happening where there's
I,
multiple
I would.
people involved?
I wouldn't call bad education lying. I'd just call it bad education. I
All
mean,
right, but how
you
many
got.
people are involved in this lie?
I mean, you
Oh, so it's not
obviously.
even a lie? You're saying it's not even lying?
You obviously missed out on a lot of science education, along with some history education.
And to
That's
the ad
not.
homs, right to the ad
Yeah.
homs.
And wasn't that harm? I'd say observation on after many years of dealing with you guys.
It's not even on topic though. How many people are involved in the? Oh, you're saying it's not a lie anymore?
Like, well, a
Are
lie.
they
See,
teaching the truth or is it false? Is it true or false?
well, that's when you get into history like this, true and false becomes gray. There's no real black
Yeah.
and white. Like you guys live in a black and white world, which is part of the issue.
All
Another ad
right, Michael
hom.
Jackson.
What? No, it's not anom. This is an observational. Again, I mean, you live in. They see everything's got to be dead nuts, or else it's false. And that's not
Well,
how science works.
history is hard to prove, obviously, because you have to, go off of basically what other people say. I mean, if we weren't around then, we have to go off of what other people have said, or maybe some artifacts if we think we can find some. But actually, this plays into a little bit what I wanted to ask you, like, because you're saying like, oh, we've known for 2,000 years, and I mean, we could open up a whole discussion on this, but I was more. I mean, we don't have to though, but just in light of this though, because it's like you don't really know what the truth maybe would be of the Revolutionary War. So could do you know that they're lying or not? Isn't that kind of what you're going off of? You're like, well, it's gray, it's black or white, it's kind of gray area because you don't know, right? So you have to go off of. But then you were saying you think there's something false about it, so there's something in you that thinks that there's something not true about it.
Well, if you look, it's a matter of how do you teach kids? You only teach kids, the easy stuff first. You don't go into right into hey, so it's history is you teach them a line of dates usually, and later
All
on
right.
you get into the it's how can I word this without sounding like
All
you
right,
gotta
but
go you gotta go easy first, and then you get hard. Start
if
right off with
the
the hard stuff.
All right, but if there is a truth about what happened during what we call the Revolutionary War, if there is a truth, something that actually happened, and then there's some human beings that were either alive then or carried it forward, and then those human beings had to carry it forward to the 1800s, 1900s, all the way to today, to where a child who's 10 years old is learning this in school. So is that chain from what actually happened all the way to what they're teaching kids today 100% true facts all the way to the bottom of the barrel of facts? Or is there some kind of fudging or lies or not telling the story correctly or something in there that's false?
Well, from everybody's viewpoint, what is true is slightly different. And especially when it comes to teaching history. I mean,
I
if you
thought
go
you
to
said it
Britain,
wasn't true. I thought you said they weren't teaching the truth.
Again, you guys made it into some huge conspiracy theory when I'm just telling you that the adult version is more difficult, more nuanced than the version they taught kids in high school, or not high school, in grade school back when I went through, especially in the still fighting the dirty commies. So our
Are
country's
they
terrorists.
teaching the kids the truth, or are they telling them things that are false?
They're teaching them a form of the truth. Not
A
you know
form
they're not
of the truth?
they're not talking. I mean, the entire truth, the whole truth, and nothing but the truth. So help me God.
So they're everything they're telling them though is the truth though. They're not telling them anything that's wrong, right?
Well, I mean, you obviously learned wrong things. So I mean, you tell me. I learned
I'm
wrong things.
asking you about this fucking George Washington thing or
Uh,
whatever. Just
the Revolutionary War is more
revolution.
complicated than what they taught you.
It's another ad hom.
Okay,
He's just trying to like get you triggered in ad hom so he doesn't have to respond to what you're asking him.
I know you see how I
It's not
started
ad
getting
hom.
excited right there. That's what
You
he
guys
does. He
keep
gets me
using
all excited,
you
and
guys
then
keep
and then
using the word ad hom incorrectly. I have not ad hommed him at
you're
all.
just
Please
talking
use the correct.
shit, bro. You're just talking
That's
shit,
not
dude.
an ad hom. An,
Whatever,
uh,
bro.
We, we,
It's worthless.
an ad hom
we
has a
don't have to
specific
we don't have
definition.
to harp on the meta, but if he's describing asking you, oh, do you think they lied, whatever, and then if you say, well, you certainly didn't learn very well, or your education was garbage, that is an ad hom, dude. You're
It's
That's
not an ad hom.
in replace of an argument, you're giving some personal tag about how he learned or his school. It's
exactly.
going to the person, not the topic. That's what
No,
ad
but
hom.
NASA also did qualify it and say I've learned wrong things. Like he was just making it as like we've all learned things. Like he did make that kind of a statement. That's the way I read it. Was the
Have
idea
you
that we've
always
all,
like not
we've
played
all.
well with others, NASA? Has this always
For
been
real,
like an
bro.
issue where
You don't play well with others.
you've been biting kids since kindergarten and just not doing things right? Like what's going on?
Well, he claims he was a highly distinguished, disciplined military officer pilot in the highest
Yeah,
military of the non-conspiratorial military.
we had
Uh-huh.
there weren't very. I tell you, there weren't any flat earthers among the pilots and air
It's
crew.
just more bullshit. You're
Yeah,
full of
because I mean
bullshittery.
that
Not a
sort of
single
attitude in the
one.
military, bro, would have got you a tune up real quick, dude.
What? There no that there are no flat earthers among pilots. That would have gotten me
What do you
what?
mean? Pilots treat the ground as if it is flat. There's
Incorrect.
you guys, you don't treat the ground as if it's curved when you're
Incorrect.
flying a fucking plane. Get
Incorrect.
out of here.
You fly great circle routes. Those are based on the globe.
Uh-huh. If you say so.
Uh,
I do say so.
It's not exclusive to the globe, dude.
It is. There's no way to have a great circle route on a flat Earth. There's no reason on the
Yeah,
flat Earth to
it's
fly
called a
from.
circle, bro.
There's no reason to fly from California to England, which we did quite a bit, and fly up over Hudson Bay on the flat Earth. You'd be over New York.
dude, he thinks he's all right, bro. All right.
There's no way to fly from Sydney to Santiago on the flat Earth with the planes we have today. It's just too damn far.
Impossible to fly on a flat Earth from
It is.
You
San
guys aren't
Diego to
even
where?
Well,
they're not even flying the
it's
right
impossible to
direction to begin
navigate.
with.
It's impossible to navigate on the flat Earth, but that's. I mean, would
You
the
guys are
airplanes
turning the whole
fly?
time.
God, conservation momentum. Please
You
tell
guys are
me.
constantly
He's just
turning.
saying words.
You're
Oh
not
my
even
God,
He just
here we
seeing
said
go.
straight.
keywords right there.
Conservation of momentum, which you guys don't
That
understand.
doesn't mean anything.
Yes, it
You're not.
does. It's everything.
You're not even flying great circle routes, bro.
We are flying great circle routes. What are you talking about?
And are
Go
you
look.
turning? Are you turning at all?
Are you turning at all? No, there's straight lines over this surface of the Earth. A
So
great
they're
So
circle
the
not.
route is
plane
a
is
straight line
turning. The plane is
over the
turning,
surface.
guys.
The plane is not
They're
turning. The
turning
plane's
left or
going in a
right.
straight line.
Yeah, we've
They're
already gone
It's
over
not
this with
turning
the
left or right.
Jamaican, bro. He had your
Plane's
plane
not
doing
turning left or
corkscrews.
right. For fuck's
they're
sake.
turn they're turning left or right for the Coriolis effect,
In,
regardless. So
well, the Coriolis effect, which is like minuscule compared to everything else, but that's okay.
great circle
I
route is
don't
when you
know.
don't turn left or right. A great
Yeah,
circle route is when you don't turn left or right, and they're turning the planes left or right.
exactly. While simultaneously saying that they're going from A to B, taking the shortest route, while simultaneously contradicting themselves.
Here you go. Here are airplanes over the
Simultaneously.
Atlantic. Why are these airplanes in a curve over the Atlantic? Why aren't they flying a straight line?
You guys say, because you guys say you got to correct for the Coriolis effect. So admittedly, you're turning
Incorrect.
left or right.
No, they're doing a great circle route over the surface of a sphere.
So
And
they're
I
not
think
adjusting.
Go ahead. I think Jeremy might have cracked this, by the way, because this is what I think this is likely what's happening in terms of
No, he's wrong.
how they conflate great circle routes and then the globe, but the Coriolis. But go ahead. I interrupted Jeremy.
No,
But I'm
no, the
just
Coriolis is like a minor effect. Yeah, winds are much stronger. You can calculate the effect of great circle, the effect of Coriolis. It's like a tenth of the winds. It's ridiculously small at 600 miles per hour.
It's not about how fast you're flying; it's about the distance you're going. Right. So
Yeah,
if
the
you're going
longer you go.
a very far distance, there's going to be a lot more correction made. It's not going to be negligible like you want to make it out to be.
Oh my
You know,
God.
because when you're taking a great circle route, it's usually going to be over long distance.
So why does an airplane flying from London to California take off out of London and go north when Los Angeles is south of London by quite a bit?
Well, you want to go the shortest distance. That's the whole point
Right.
from A to B.
Over Great
But
Circle, which is the Great Circle route over the surface of the sphere.
the point
No, it's
is you're
not. It's the one where you
Yes,
don't turn
it
left or
is.
right.
Jeremy,
No,
if
that's
the,
the
you,
whole
you can
the
point.
shortest
if
the
you can come up
shortest
with
route. Hold on, Dicelo. The shortest route is when you don't turn left or right. That's why a great circle route is the shortest path on the surface of a sphere, because you don't turn left or right. The
you're
planes,
good.
admittedly, are adjusting for the Coriolis effect in turning left or right.
They're supposed to be.
Again, show me mathematically the Jeremy routes. Please do so. You haven't
We
calculated.
just laid it
You
out. He
haven't
just
calculated.
laid it out
You
for you.
haven't. You
It's not a
haven't.
response to what I said. I
Yes, it
know.
is. It's exactly the response. You say you have postulated that there is a better route that's shorter. Please show me with that route.
He just laid it out for you.
He
He
didn't
told
though. He
you.
just
He
postulated
told
something. It's a
you. Listen,
hypothesis.
listen. He told you to account for the Coriolis effect
It's a hypothesis.
before you ever get in the plane and take
That's
off.
not my job
You're
to
not
prove
doing
it.
that, but you guys aren't
Not,
doing that.
it's not my job to prove his theory
No,
or his
no,
hypothesis.
no one's making this a theory. This is a fact,
No, it's not
a
a fact.
mathematical
Show
fact.
me. Show me it. Show me the math.
Facts.
The,
It's a mathematical fact. Show me the math.
dude,
Facts machines.
you clearly didn't go to school if you didn't
I
learn
clearly
this.
went to school. I
Yeah,
clearly
you
went
didn't
to
learn
school.
good. I'm about to start ad hominem
I
all the shit he
clearly,
does. That.
I
He didn't learn
clearly
good.
went to pilot training, and I clearly took a course in navigation, and I clearly understand great circle routes, which you apparently do not. Is
This
that
is
not
just
how?
basic. These are
Joe, is
basic
that not how?
mathematical facts, dude. The
Then show
shortest
me the math.
distance between 2 points from A to B is a straight line.
Show me the math.
Do you disagree?
Show me the math. If you
Do
say
you
it's
disagree?
mathematically proven, if you say it's mathematically proven, show me the math.
Just trying to find common ground with you, man.
Show me the
You
math.
okay? Let me know when you're done chanting.
Well, let me know when you have the math. If you say it's mathematically proven, show me the math.
I'm trying to give it to you. This is a
No, you're
mathematical
not.
fact.
You're talking without saying you're asserting this mathematical fact without showing me the math.
Yeah, can I make a fact
Then
here,
show
dude?
me the
This is a
math.
factoid. Okay, are you ready to listen?
I want math. If you're going to say it's mathematically proven, show me the math
Yeah, this is a math fact, dude.
and show me the math.
He wants it in number format. Is that what you're asking for? Number format?
Yeah, yeah, that's what math is usually with numbers.
So you want me to talk to you in numbers? You're gonna
No, I
understand
want
what's
you to
being
show
said.
me the math. I want you to copy me the math. Here's London. See, here's the route from London
Jeremy,
to.
can you draw him a picture on the whiteboard, dude?
Don't draw me the picture. I want the math. Here's London to.
You're saying that there's no words in math?
Show me the math. Math has math. You know, like
Does math
numbers.
not have facts? Does math have facts?
Now show me the math. You say math. You say this is mathematically proven. Show me the math.
I feel like you're being combative.
I'm being combative. You're telling me that this is mathematically proven and not offering me math. You're offering me just words.
Yeah, there's words in math. There's mathematical
There's
facts.
math in math. There's more math in math than there's words.
Yeah, that's fair.
So show me the
But
math.
there are mathematical facts, and this is one of the facts I'm
Show me
trying
the
to give
math.
you that you should have learned in like geometry
Show
or
me the
something.
math. Show me the math. If you say it's mathematically proven, show me the math. Or shut the fuck up. How about that?
Well, I think you're asking for unreasonable things that you don't.
I'm
I
asking
don't
for
even think you can
unreasonable things.
make
I'm
sense
asking
of
for
what you're
I'm
asking for.
asking for an unreasonable thing. When you say it's mathematically proven, I ask for the math that shows it's mathematically proven. That's unreasonable.
Yeah, yeah. When we're talking about
Wait a minute, hold on,
facts
hold
here.
on. So I'm asking you saying it's mathematically proven. I asked to see the mathematical proof, and you say that's unreasonable.
I'm giving it to you, but
No, you're
what you
not. You're
want,
not offering me math at all.
doesn't
I want
comport.
math. I want math, not words. Or you can stop saying that it's mathematically
So when you
proven.
say math, define that.
Define math. How about numbers, signs? The language of math. You obviously don't speak.
So you want numbers and signs to
Yeah, I
define
want numbers. I want the proof. If
to,
you
to
say this is
define a.
if you say this is mathematically proven, show me the math or shut the fuck up.
All right, let's see how Google responds to this. Give me a minute.
No, I don't want Google. I want your math. I want you to admit that you don't have mathematical proof. So you're going to Google something now, so you don't have the math.
True, yes or no? Is that why it's a
Okay.
short? You want the math for how much? If you don't adjust for the Coriolis effect, how much you're going to miss the airport by? Like, what math do you want exactly?
I put it in chat for you. It's there in chat.
All right, there you go, Paid. He gave you the math. Is that it? I don't know. Check it
No,
out.
that's not it.
That's not it. What math do you want exactly?
Well, I want the proof of the Jeremy path, that there's a shorter path than the Great Circle Route.
Yeah, if you don't turn, the Great Circle Route is a shorter path because you don't turn left or right, correct? Yes or no?
Okay.
Is that true? Yes or no? Is that why it's
Okay.
the shortest path because you don't turn left or right?
Okay, I guess you could say that.
What do you mean you guess you could say that? Is that why the Great Circle Route is the shortest route because you don't turn
Great
left or
Circle
right?
Great Circle Route's the mathematically calculated route over a sphere by
Why?
definition. It's the shortest
Why? Why though? Why?
because it's measurably shorter than any other path.
Because you don't turn left or right.
Okay, I guess you
If
could
you
say
turn
that.
left or right, would it be longer?
I guess you could. You do have to correct for winds, though. Does that make it
So so
incorrect
you
now?
so you agree. If you don't turn left or right, you've went the shortest path,
I
right?
don't think that's the definition of the shortest path, but
That
we'll
is
just let's give it.
literally the definition of the
Yeah,
shortest path.
show me. Please show me that
Not turning
definition.
left or right.
Show me that definition. That's the Great Circle Route is defined by not turning left or right. I'd like to
The
see that.
straightest distance between 2 points is a straight line, bro. Do you deny that?
Over whose geometry?
Over any
Any
geometry,
geometry,
Incorrect.
literally.
in spherical geometry, it would be called a great circle route where you don't turn left or right.
I don't think that's in the definition of a Great Circle Route anywhere I've ever seen, but I said, let's call it a working definition for.
It's literally in the definition, dude.
Bro,
I can
you're
read it
Show
to
me,
bugging,
you.
show
dude.
me,
You're
show
it's
me,
pointless with you,
show me,
dude.
show
It's
me,
I can read
absolutely
it
show
to
me.
you.
pointless.
Show me where it says not turning left or right means the shortest path. I'd like to see that.
That's why a great circle route, if you turn left or right, you're not doing a great circle route and
Yeah,
you're not doing the shortest path.
I'm gonna
Like,
read
this
it.
is like obvious. You need a
It is
definition for this,
obvious.
bro. Like, what the
It says,
fuck, dude?
It's
right
obvious.
here. It says
Where's the
right here.
definition?
Can you hear me?
Well, again,
Spherical geometry on a sphere. The shortest path between 2 points on a surface is an arc of a great circle, a circle with the same center at the sphere. This is why airline flights path appear curved on flat maps. They are actually following the straightest possible path along the Earth's curvature to save fuel. And then it
correct.
gets into hyperbolic geometry, which would be a
Show me
saddle
show me that
shape.
link. Let me see that link. That sounds like a good link.
Okay.
Dude, if you turn left or right, you're not on a great circle route and you've went a longer path. If you don't turn
Right.
left or right, if you don't turn left or right, you've went on a great circle path and you've went the shortest path. Do you know why? Because not turning left or right is always the shortest path. Like
Yeah.
we
Oh, you're
can't even
reading
get
that.
that straight. Fuck the Coriolis thing and everything after that. None of that even matters. If you don't understand that not turning left or right is the shortest path, you shouldn't be debating the next part at all.
Well, see,
You're
that's
not
not
even
in the
ready for the
definition.
next part.
That's
You're
not
not
really
even
in the
ready for the next part, dude.
that's not in the definition of a great circle route. The
What do
definition
you
of
mean?
great
It's right there. I posted it.
the definition of a great, you did posted something from AI.
What? I posted it from Google.
Yeah, which is gave us the AI definition right off the top.
I read it to you. It says non-Euclidean geometry. I can read it again, and then it's talking about on curved surfaces such as the Earth. The shortest distance is called a geodesic. All right.
Well, the link you gave me isn't the same one you're reading from. I can see.
Yeah, it is.
Dude,
Gotta scroll down.
a great
Number
circle
2.
route is this. A great circle route is the shortest path on the surface of a sphere because you don't turn left or right, bro. How hard is that to understand?
But that's not in the definition, Jeremy. The definition goes with math. It's not I guess you could say that that is a byproduct of it, but that's not really the definition of a great circle route. Sorry.
If you turn left or right, did you go the shortest path?
Okay, let's try it again. The
Paid. If you turn
definition.
left or right, did you forget the definition? This is a
Forget the
simple
definition.
question. This is a simple question. If you're going somewhere and you turn left or right, did you go the shortest path?
Well,
Jeremy, Nessa, can I just ask Jeremy something? So if you were going in a straight line, which is your shortest path, and there was a force pushing you left or right, and you push against to go to the straightest path, isn't that the same thing?
A
It says right
forest?
here.
You
It
say a
says right here
forest
on
or a
Same
Google.
floor?
thing. So they're turning left and right to stay on the straight path.
I don't know. He sounds confused. It says right here, dude, on Google, dude.
What do you mean
You
it's
do need.
confusing?
I don't know. You're
Literally,
bringing up.
if you're going in a straight line and there's a force pushing you left and right, you're gonna want to turn left and right to stay on the straight path.
No. We're not accounting for that. It says
No.
right here. Listen up, dude. It says right here you do neither. A great circle route represents a straight line on the surface of the Earth. Assuming no wind, an aircraft or ship simply maintains a continuous straight heading to the destination without physically turning left or right. That's what it says. Google it. Ask Google, do you turn left or right on a great circle route? See what it says.
That's for
No
accounting for no
tricksies.
and everything, though.
Yeah,
Yeah,
assuming
no
no
wind.
You
wind.
literally
Yeah, like
said it. You literally said it.
yeah.
Yeah.
Assuming no other forces, right, are pushing you around, detouring, retracting you from making your straight path. Yes, you would travel straight.
But there are
Dude,
always winds. So what
even if
Jeremy
there was
suggests is
wind,
that pilots turn left and right. But you will
but
What's
be
even
that?
if
turning
there
left and
was
right
wind,
if there's wind. If there's wind.
yeah, even if
Yeah, we're
there
not.
was wind, hold on, man. Even
He
if there
just said
was
it though.
wind,
He just said it though. As long as
We're
there's
not
no
worried
wind.
about it, dude. Yeah, we're not worried about that. I'm not. I'm not saying like, oh, you didn't do it if you got bumped around by the wind a little bit. We're asking what the intention is here. Is the
Yes.
intention to take a straight path here? And he can't even answer the fucking question. He's
No, to
incredulous,
stay
and then he
on
runs away.
to stay on the great circle path, you have to turn left or right. If there's wind.
Yeah. Even if
Yeah, we're
there
not
was wind. Hold on, man. Even
He
if there
just said
was
it though.
wind.
He just said it though. As long as
we're
there's
not
no
worried
wind.
about it, dude. Yeah, we're not worried about that. I'm not saying like, oh, you didn't do it if you got bumped around by the wind a little bit. We're asking what the intention is here. Is the
Yes.
intention to take a straight path here? And he can't even answer the fucking question. He's
No, to
incredulous,
stay
and then he
on
runs away.
to stay on the great circle path, you have to turn left or right.
No,
That's
no,
the deal. Yes, because there is
absolutely
wind.
not.
Of course.
Oh, come on, bro. We're
They,
not.
they
And their
already,
model,
You're,
and their model, they say
dude,
you
they
have to
already
stay.
told you as long as you not account for this thing, then you can go in a straight path. But
listen.
Yeah.
there is that thing that pushes you left and right.
Yeah, nobody's denying that, dude. And
No, it doesn't
we're
push
not
you
just.
left or right. I am denying
Yeah,
that. It doesn't
he
push you
is.
left or
Jeremy
right.
is.
There is no force. The Coriolis force is not an actual force. It's a pseudo force. There's nothing pushing you left or right, dude, from the Coriolis. I don't know if you knew that or not, but
If
nothing
you're
pushes
moving,
the
Coriolis force
nothing
does
push.
affect you. If you're moving,
Bro,
it
I
does.
can 100% prove that that's not true.
You can 100% prove that
That
it's
that's
not
not
true
true.
that
What you said is not true.
Coriolis
Yeah.
effect moves a moving object.
Yes, 100%.
Oh my! Then what is
Do,
physics?
do you want to hear how? This is physics. Do you want to hear how?
Okay.
Yeah, you throw a ball in a straight line. You and your buddy go to the park, throw a ball in a straight line, right? The ball. What's so funny?
Do it on a merry-go-round.
Yeah, we're gonna get to the merry-go-round. Just listen. You and your buddy go to the park, throw the ball in a straight line back and forth. Somebody comes and stalls a merry-go-round in between you two, and somebody gets on it and starts viewing the ball. There is no force, and you guys keep throwing the ball back and forth. They're spinning underneath it. There's no force that's magically
No,
making the ball move. There's no force that's magically making the ball move left or right.
dude.
The ball is still
What if
just going in a straight line back and forth.
the person was on the merry-go-round when they threw it?
It doesn't matter. The ball's still
Of
going
course it
back and
does.
forth in a straight. The
Of course
ball's
it
still
does.
just going back and forth in a straight line. There's no force pushing the
So
ball. You
if the
Newtonian
merry-go-round was
physics.
going around,
Newtonian physics falls apart when it comes to non-inertial reference frames, bro, because of this. Just yeah.
Welcome to Flat Earth, bro.
Well,
That's just physics. That's
the
fucking
point.
physics right there.
Well, the point he brought up was a separate scenario. If you're on the merry-go-round and then you're going to throw a ball, that's different than if you're viewing it from a non-inertial reference frame.
No, even if you throw the ball off the merry-go-round, it still just goes in a straight line. There's no force making it curve. It just looks like it's curving because you're rotating under it.
It's the
yeah,
same
but to
thing with
get to
like
the
the David and
destination,
Goliath swing,
but
like
if the
where he's
person that you're throwing it to is on the other side of the merry-go-round as it's turning, you want to be able to get to that destination, so you turn left on an airplane. That's the point of Coriolis.
Yeah, but if you wanted to take the shortest path, you would fly the way the bullet does. You would shoot where the target's. You wouldn't shoot at the target. You wouldn't turn the bullet left or right. You'd want the bullet to go in a straight line and just hit the target. It'd be a shorter path, not turning left or right, obviously.
yeah. Yep. I don't know what's so complicated about this, dude.
It's not complicated, I know. It's not.
It's like I don't know. And then the guy, and then fucking dude just leaves. You know, Paige left. This guy left. It's just, is this like something they never thought about before?
The whole idea of the shortest path, like if I drew a line on the ground, right, from A to B, and I put you in a car and the wind was blowing fierce, and you had to turn to stay on that straight line path. If you stay on that straight line path, it was still the straight line path. You know what I'm saying? It was still the shortest path. If wind blows you off the line, and then yeah, you're not on the path anymore. But this Coriolis thing's a whole different ballgame. It's not wind. Wind's not really relevant when you're talking about it.
Well, that's what I was trying to tell this guy, and he's like, "Oh, because there's wind and the wind's gonna blow you, therefore you can't." And it's just like, no, bro, it's not how that works, dude. It's not how that works. The whole point is leading the target, dude, versus chasing the target. And these guys just don't get that concept. It's like they've never thrown a football a day in their life, dude. You know, they've never had a guy go run a fucking short route, or I don't know. I mean, multiple examples of leading a target versus chasing a target.
You can tell which one is the shorter one. I like the example with the drone, and you got to get to the edge of the drone, but you only got enough energy to fly 1 meter, and the radius is 1 meter at a drone of the merry-go-round, and you only have enough energy to fly 1 meter. You're gonna fly in a straight line to the edge. You're gonna lead the target or whatever you're trying to do, and fly that straight line route. Otherwise, you won't make it because you're flying a longer path. And if you try to turn left or right and adjust for the Coriolis effect, you'll never make it to the edge.
Did Paige try saying he flew the Blackbird, the SR-71?
He refueled it.
He said he flew the
Yep.
plane and refueled it.
They do mid-air refuelings.
By the way, this is one thing just about like this format where it's like 24 hours, people come in and out. Like the fact that you guys were kind of debating those guys and they both just disappeared. I'm just saying it is kind of one of the less ideal things about this format. Like, if it was like a show we were doing, or if it was like a more of a plain debate, or if they were gonna actually be here for 2 hours and get to the bottom of it, go through it, and you can actually like hold someone's feet to the fire more so. The fact they can just kind of dip out. And I get it, people, there's a good thing about it, people can jump in and out throughout the different times in their day, but it also kind of leaves you hanging sometimes when like you're right on a point and then they just disappear.
So Paige was basically like the water boy for fucking Top Gun.
I don't
bro.
know, dude. He says he was on the pilot team that was piloting the actual ship. He even said he was captain. Or he was an assistant, and then he ended up being captain. I mean, that's what he says. So
Of
it's
the
kind
ship
of
that refuels it, though.
Yeah, that's my point. It's like here's your water, dude. Get back in there.
okay. I hear you,
He's a
but
fucking
that's
water
still...
boy, bro.
All right. But I mean, that's all right. But how many people
Fucking
have?
paid NASA Boucher.
All
His name
right.
was Bobby Boucher and the water boy.
If Bobby Boucher and Top Gun had a baby, it would be Paige. Yeah.
What's up, Gio? Get us on something here.
What do you want to get on?
I don't know, I'm about to try one of these glass tips I bought from the dispensary, though. Shit's about to get fucking real.
Get on some weed. I don't know. You want to talk about Iboga? Jeremy, with that whole like path of the flights, do you actually think that it's possible that they're actually flying a left to right curved path on the ground and then conflating that as a great circle route on the globe?
Dude, they could be using it to cover up distances or actual things. Like, who knows, bro? I know your idea on it, and I mean, maybe. I don't. I mean, they wouldn't say it's that much of a curve though that they're doing, but then they say they got the winds and everything. Like, who knows? Like using planes to do anything is just like I wouldn't do it.
Yeah, but do you think there is a Coriolis effect on a stationary planar Earth? Like, do you think there is an actual effect that they would have to account for that is actually happening?
It could be, yeah. It could be that effect could be there. Like, I don't
I
even
mean,
argue with them that it's there or not there. They got it in the manuals and they say they're doing it, whatever. I just go with it. But maybe it's there, maybe it's not.
Well, I mean, you got the pendulum drift and the claim that bullets drift, which some think would be connected to ether or somehow the movement of the sky and so on. It's relating down to the ground through the medium. So if that was happening and they actually are accounting for it, how does that change the argument?
Well, if it was a real thing that was happening, though, it would be the same in both frames. And then my argument doesn't even make sense anymore. Because
how could a
you only
visual
have the
effect
core,
do something? But you're still on that, bro. You're still on that.
Geo, you only get, if it was a real thing happening, it would look the same from everywhere. You know what I'm saying? Whereas the Coriolis effect, there's these two different frames. I know, see, I know. It's just a visual thing. I've actually debated that it is a visual thing before, and I still agree. It's
But
optical.
didn't you just say that it could be real? Like,
No,
I
I'm
want to wash
saying
the demons out of you, bro, completely.
No, it absolutely
no.
could be real. Yes. There's claimed to be a preferred direction of light that's different in the northern region, north of the equator, hemisplane, hemisphere, whatever you want to call it, versus the south. There's the Foucault pendulum, which is claimed to drift clockwise and counterclockwise. You've got the stars that are clockwise and counterclockwise. You have the wind patterns like hurricanes that seem to kind of whip up going clockwise in the north and then whip down going counterclockwise in the south. So yeah, it absolutely may be a very real thing, and the drift of
Yeah,
bullets as well.
yeah. Geo
Well,
asked
hold
me
on, hold on.
if
Let me respond to Gio. If the Earth is spinning, that's one thing. But we're talking about the Coriolis. Coriolis, Gio, is visual. There's no effect. There's no force. There's no nothing, bro.
I know that's what I was saying. If they are actually correcting for these things with ballistics and planes or whatever, if something's happening that's making things deviate, then I think it could be a real deviation. It just wouldn't be the Coriolis effect, and my whole argument of the thing falls apart right there with the leading the
Isn't it?
E-
target because
Isn't it
Exactly.
openly? Isn't it openly admitted on their end that in order to prove Coriolis, you have to be outside the reference frame?
Well, yeah, that's the whole thing. You need two reference frames, one inertial and one non inertial.
Well, you have to be in the non-inertial reference frame. Like you can't prove it from the inertial reference frame, like from the terrestrial perspective.
Yeah, because if you're on the inertial reference frame, you're not moving, and the ball appears to be going straight. I mean, it's clear cut.
I mean, isn't this openly admitted on their end?
Well, there seems to be some people confuse it, right? Like the rotation, what Gio was saying before, the rotation of things spinning and this and that. That would be an actual spinning of the Earth, right? Now, the Coriolis is simply a visual effect witnessed from the non-inertial reference frame.
I'm telling you, the way to do Foucault pendulum is you get a friggin' accelerometer inside the thing or on it or something. Because if it's Foucault, if it's Coriolis, there's not going to be a left to right force ever. But if it's the real thing and it actually is the thing, Geo, with the something ether swirl or something, then there might be a force there, a real force. I don't know. Who knows?
Yeah, I don't think it is only visual either. I don't really think that's the whole story. I understand why that's said. I think from one perspective, it can be seen as visual. Just for fun, I typed it into both Gemini AI and ChatGPT, and both of them say that Coriolis is not just a visual effect. I don't think
Yeah,
it
no,
is
I'm
only
all over it.
visual.
Well,
It,
I could prove that it is visual though, because if the guy like that scenario where me and you go to a park, we throw a ball back and forth in a straight line. So the ball's just going in a straight line. Then if you install a merry-go-round, somebody spins underneath it, they're going to see the Coriolis effect. Like nothing, it's just an optical thing because you're spinning under it. And
that one kind of is, yeah. Like
it's the
that.
Coriolis. That's the Coriolis effect, though. Even if you throw a ball off of the thing, it still goes in the straight line. It's just optical to everyone on it that it didn't.
Yeah, but they don't
Yeah,
claim that's all of what Coriolis is, though. Like they claim that the spin of the Earth, or if you were to replace that, the spin of the ether. But but let's just say the spin of the Earth one is actually causing the hurricanes to rotate clockwise and counterclockwise, or cause the pendulum, which is related to Coriolis, to actually process differently. Although they're going to claim, oh, it's the Earth that's rotating under it. So in that sense, it's visual, but I guess it kind of depends on what framework you're referring to it.
no, but Gio, you're assuming right there that the Earth is spinning.
That's what their model says, or the ether is causing it. Yeah.
Yeah, but the Coriolis is not that. The Coriolis is the apparent, and they even say pseudoforce, apparent. It's the apparent visual effect of when the ball leaves your hand on a merry-go-round, it travels in a straight line, but it appears to the people spinning, the spinning reference frame, the non-inertial reference frame, that the ball is curving, but there's actual no curve there. So even by their definition, it's strictly visual.
It's not though. That's not how they describe it. Like, let me read this real here. That's one version of it. That's one way. I think one of the issues is that the word Coriolis, like that was the name of a guy, Coriolis, and he was doing a bunch of little tests with like little physical systems, little rotating things, and so this kind of like name got applied to him as like this effect of the Earth, and of course they're going to claim the Earth is rotating. But even in their model, like I mean, this is the Gemini AI. It says, I'll just read this real quick. It says, real world physical impacts. If it were only a visual effect, it wouldn't physically alter the course of objects. However, because we are bound to Earth's rotating frame of reference, we have to account for it in physics, meteorology, and aviation. So then it talks about weather systems that actually cause them to go clockwise and
Hold on,
counterclockwise.
Gio.
Aviation.
But
and
you just said it yourself, Gio. They just said it. If the Earth is rotating, you just said it.
Hold on. Just run that back a paragraph, Gio, real quick. Let me interject when you hit the spot.
It says, if it were only a visual effect, it wouldn't physically alter the course of objects.
All right,
However,
stop right there. Stop right there. It doesn't alter the course of objects. That's the thing. Coriolis doesn't do that. It just makes them appear to have been deviated because you're on a rotating thing. Like from the inertial frame, they're not. It's still going straight, just like the example of when you throw the ball off the merry-go-round. It's
It's
still
the
just
next
going straight.
sentence, Jeremy, that kills the thing. Let him read the next sentence.
yeah, they claim that Earth
Back
is a
up.
rotating frame of reference. That's what they claim. But if it's ether that's actually moving it, then it's the ether that's the rotating frame, and the ground is stationary. Because they're kind of like, if you shoot a bullet and you shoot it straight, I guess they would say like from outer space, or if you shoot it off on the globe from outer space, you would see that bullet just traveling straight. But because the Earth is rotating under it, it's going to actually deviate, on the actual ground from left to right. Let's say in that example. But they're just saying the Earth is a thing rotating. Same with the Foucault pendulum. They actually claim the pendulum's not processing; it's the Earth under it. But if you flip that and you say that the Earth is stationary and the pendulum is actually rotating, or the bullet, or the clouds, or the wind patterns, ocean currents, etc., then it is actually those things actually being deviated. Like they're the thing that's in the rotating reference frame that is actually moving upon the stationary Earth. So it's kind of just inverted one way or the other. And it is true that, yeah, on a stationary Earth, it would be more of an effect potentially than the globe explanation, which claims that the globe is the thing moving under it.
I think you're a bit
Yeah,
confused.
with the globe. Hold on, real quick, Esty. With the globe, it's optical. Despite what Chad GPT or these guys say, it's an optical thing. It's not from the inertial frame. It would go in the great circle route, straight line. But to us, it's deviating. That's just the Coriolis. If it was our thing on a stationary Earth, then yes, it would be a real thing.
Look, it's confusing the way they explain it. It's like they double talk. See what Gio read? They say it correctly in the beginning, and then the second sentence is, but the earth is turning. Like, read that thing again, Gio, and you'll see what I mean. Read it out again. If you still have it handy.
Well, now I just did another prompt. If you want me to read that one. However, because we are bound to Earth's rotating frame of reference, we have to account for it in physics, meteorology, and aviation. Is that the part?
That's it, right there. Right there, yeah.
Well, the thing I just typed another thing. I said, does the Coriolis effect actually physically push or move things like weather storms or ocean currents? And it says, yes, the Coriolis effect actually physically alters the paths of weather storms and ocean currents. While physicists call it a fictitious or apparent force, this is just technical jargon, meaning the force originates from a rotating frame of reference rather than a physical push like an explosion or magnet. So this is kind of like
you said it again. Sorry to interrupt you, but you said it again. It originates from a rotating frame of reference. So they're assuming right there.
Yeah, but Gio, I know they're going to say that, but the Coriolis effect doesn't alter the paths of feed it the scenario I give with the merry-go-round. Like feed it that scenario. If not, I'm going to do it when I'm done cleaning up the kitchen and shit. But I'm going to feed it my example because you'd have it trapped right now if you feed it my example. You know what I'm saying?
Look, it's clear cut, Jeremy. Both things you read assumes that the Earth is rotating. Both
We
things feel out.
We get that, but if it were rotating, would it do that? If it were,
it deflects. Yeah, it deflects something that goes off the rotating. Like if you're on something that's rotating, you throw something. It's obviously going to act differently when you throw the ball off of. Like if you're on a merry-go-round or whatever, the fact that you already have that implied motion is going to affect it, which is kind of what they're saying. It deflects it or kind of steers it. Sort of like a little bit like if you're in a car and you turn really hard to the left, and then your body pushes up against the door to the right. It's like the centrifugal force like that. Like no one's pushing you, but the fact that you're on a thing that's moving is the thing that ends up pushing you. So it's like the bullet deflecting has to do with the fact that they claim that you're on a ball that's rotating, but if it's the ether, then it would just be the ether that's causing it.
Well, let's leave the ether out of it for now. So what you just said right there, even if something is rotating, right? Like a slingshot, right? It's rotating. But once you let go, that rock travels in a straight line. That's another misconception that people have. I know this is a bit complicated, right? But once you let go, it travels in a straight line, even if it's rotating. Does that make sense? I know they try to pull conservation of momentum and this and that and the other thing, but that is a truism. Once you let it go, it travels in a straight line. Otherwise, the merry-go-round experiment wouldn't work.
Yeah, but that's not really the whole
because
story. I mean, that's part of it from that kind of viewpoint of it. But I mean, they claim that the hurricanes are actually going clockwise. Like they're not going straight. They're actually making circles. They go
Yeah,
from
Gio,
Yes.
but that's not that's
making
due.
circles.
Yeah, but
the
that's due
sphere,
to the Earth actual turning in their brain. It's not because of the
This
Coriolis.
the sphere and the tabletop, they're not one-to-one analogies. If you imagine the vector direction, they're different when it's a globe rotating and a flat tabletop thing rotating. There's an extra axis of a directional movement that a ball rotating you'd get versus a flat table thing working. So that like setting a camera and throwing a ball and stuff, these are not perfect analogies. It's only to a degree, only for its case. So
That's a good point, Kate Breaker. And yeah, and also every time there's like an acceleration, that would be like it would be moving into the inertial frame, and there's this constant acceleration turning of the Earth that would also turn in this rotating fashion.
I think you guys are failing to see the most fundamental part of this. But hey, I tried. I tried.
Yeah, but I mean, discussions don't always have to be cramming something. I'm not saying you're doing that, but like, you don't have to like put something in someone's mind and then make them like see it your way. Discussions can just be like what you think is true, what someone else thinks is true, put it forth. Everyone can mull on it, think it over. You know what I mean? Like, every conversation doesn't have to be like, I tried to get it in your head and it didn't get in there. You know what I'm saying? Like, doesn't have to always be that. Like,
Yeah, but
so.
Gio, I'm not trying to do that. I tried a few times to explain what the actual Coriolis is in their model, in the explanation. The ball travels in a straight line once you let it go. There's no disputing that. There's no, well, let's debate this, right? There's no debate in that. That is what it is. Like, I hope I'm not coming off too strong, but how many times do you have to say something? This is not up to debate.
That's just their interpretation of it, though, because what it actually would be doing, like the bullet that they would claim, for example, is actually deviating, like the soil on the ground, like the dirt. Like, if you had a straight line drawn on the ground and you shot the bullet, their claim is that that bullet would deviate from that straight line. It would actually move to the right. Like, the actual dirt that it's over, the rocks, the soil, it would be over different dirt, rocks, and soil other than that straight line. So, like, the claim of that, like, let's just say for a minute the bullet does do that. Let's just say, I know that's a whole debated thing as well, but let's just say it does, or throwing a ball or whatever, that it is actually deviating. It is actually moving on a different part of the ground. They just claim that it's the Earth rotating under it versus the bullet actually just doing it. And if you have a stationary Earth, then the bullet actually just is moving to the right. And then, but what they're claiming is that it's going straight and the Earth is moving under it. So yeah, it's just a different frame of what they're describing. But the actual thing that's happening is that the bullet is moving left to right on the actual Earth.
No, bro, no. This is what you're not getting. The bullet is always going straight. And what you just said about the ground deviating, yeah, because the ground is moving, not the bullet, bro. The bullet is always going straight. This is what you have to understand, bro. And I'm not trying to ram it down your throat. I'm just telling you what it is. That's their explanation.
No, it doesn't their straight also curve due to gravity, due to forces, whatever. And
No, it goes down. It goes down. It travels straight and down. Just like the ball,
yeah, but
right? Because of gravity. There's no buts, bro.
well, it's just that their down is constantly changing at every point.
Look, I'm telling you guys, that is the actual explanation. Now, I'm not trying to be forceful. I'm not trying to ram it down your throat. I'm just explaining to you what the proper explanation of the Coriolis is in their model. In their model, I'm not making it up. That's what it is. And Gio said it, right? When the bullet travels straight from the ground, it appears that it's curving. And yeah, it's going straight and it's moving over the ground is turning, right? Because the ground is turning, not the bullet. The bullet is always traveling in a straight line. That's what it is, guys. What can I tell you?
Yeah, that's just their
Gio, can you
explanation
feed
of
it?
it, though. It's just their explanation saying the ground curves under it, because the actual ball or the bullet or whatever is actually curving, let's say left to right. So that, like, same with the Foucault pendulum, like we could all sit there and watch it actually process, let's say, like it's actually moving, So we could all say, yep, that's moving. That is absolutely moving. Yep, it's in a different place in comparison to the ground as it was 5 minutes ago, 10 minutes ago, whatever. But they're just going to say, well, no, actually, it's just the earth under it that's moving. The pendulum is actually just swinging back and forth. But in order to know that, you'd have to like go outside of the entire reference frame from outer space or a God mode, or there'd have to be some other way to confirm that it actually is moving under it.
Couldn't you
So
just look at the pivot on like the where the pivot is, right? And say like make a little mark right at the center and say, okay, now it's not at that mark anymore. Now it's pivoting in a different place on the pivot and say, so now we know it's the ground didn't move. It's in a different it's at a different mark. And then you know it's what's moving. So right, like it's swinging back and forth. Like so, if I imagine it swinging back and forth, and I put a little mark there. So here's the center of the arm, and it still stays at the center of the arm, but it's knocking pins over on the ground. I'll say, yeah, man, I guess something is moving underneath of it. But since it's at a different place in the pivot, the arm is at a different place in the pivot. Then I know it's the arm moving. That seems pretty obvious.
for me to, I'd have to hear that again to understand fully what you're saying. If unless someone else wants to respond, could you say that again?
Well, all I'm really saying is if you have if I have a string, right, and you say, okay, look, it's hitting, it's hanging from a rope, right, or it's hanging from a I don't know, eye hook or something like that, right, and you see, there's something around that eye hook and it's tapping back and forth on that eye hook, right. So you put a little mark on there and you say, okay, it's oscillating in this plane. I'm going to mark that on the ceiling, right. So now, if if it keeps swinging, and now it's not swinging in that plane anymore, then you know the arm moved, not the ground underneath of it.
Well, I guess that's the thing that's in contention. Which one's moving?
No,
Like this.
it's not in the same plane. It's the ball is in the air, and it's not. It's swinging in either the same plane or a different plane.
Well, that's the thing. You
You
have
know.
like you have the ground, you have like the air, and then you have what they would call like outer space. That there's this other frame, basically, that's containing the air and the earth, rather than just there being air and earth. Like if there's just air and earth is stationary, and then the air is what it is, then yeah, there's one thing that's moving in relation to another. But when you add this outer space thing, like I just typed another quick prompt into this Gemini thing, and here's what it says. Because I was saying if you throw a ball in a straight line or whatever, it says because the Coriolis effect is a result of a rotating frame of reference, the exact same throw would look straight to someone in space, but a curved line to someone on the Earth. So a bullet or a ball, whatever. They're saying, yeah, if you're in outer space, it would just be the thing would be going straight, but to someone on Earth, it's curving. The thing is, we're on Earth. None of us are in space. No one's out there in this other reference frame they claim is out there. The one that SE is saying that, like, well, it's actually going straight. Well, who has proof that it's actually going straight? An astronaut? Some government agent dude who claims he's up there? You know what I'm saying? So it's like on Earth, it's just curving. It's just an actual curved line. Like you, me, on Earth, bullet curving. That's it. That's the only thing we can. They just claim that in outer space, it's going straight. But on the ground, it actually is curving, which is why they claim they have to, they have to put the target to the right or whatever, and they have to account for it.
You don't have to be in outer space, though, Gio. This is another mumbo jumbo from the AI, right? All you need is a camera above the merry-go-round. If you have a camera just above the merry-go-round, you'll see the ball traveling straight. And if you have a camera on the turning merry-go-round, it's going to look like it's curving. You don't need to be in outer space.
All right, but if you shot the bullet and you had a drone that was, you know, a mile up or whatever, 1,000 feet or whatever, the bullet would look like it's curving.
No.
Because they
It
would claim
wouldn't.
the drone is in the reference frame of the air that they claim is rotating with the ball. Therefore, you're still in the same reference frame. Basically, if I'm on the ground or if you have a drone that's a mile up, they claim that we're all in that big rotating ball, and the bullet is curving, which is why they claim they have to account for the deviation when the target is, it actually curves to the right or left.
Right. You just caught another double speak of theirs. Exactly. If that was the case, what you said, then there wouldn't be no Coriolis because everything would be turning at the same time. So there would be no inertial reference frame. You just said another con job of their Coriolis.
I don't necessarily think Coriolis is a con job. I think it was just inverted into their globe model, and then they call it a fictitious force when it actually is a real force. So, I mean, I don't think it is a total con. I think the effect is real. They just have to explain it by claiming the Earth is rotating. I mean, are you saying that hurricanes don't do clockwise, counterclockwise, the pendulum doesn't precess, the bullet doesn't drift? Like all the things they claim, are you saying that none of those are real?
No, what I'm saying is that those effects you would need something rotating. Actual, like if you want to claim that the hurricane affects something, there would have to be an actual rotation of the Earth, and that is not the Coriolis effect. This is where the misunderstanding is, I think.
No, but
The
it would be
Coriolis
either
effect.
like there's let's say there's three main categories. Number one, this effect doesn't exist at all. Like let's say pendulums don't drift, hurricane, it's just none of it's real. Number two, it is real, and it's because we're on a big rotating ball, is what they're going to say. Number three, it is real, and there's some force, whether you call that ether drift or something in the medium, electromagnetics, whatever is going on over a stationary type Earth that is causing it. Like, would we agree that those three categories? It's either not happening, it's the globe explanation, or it's ether or some other explanation as to how it's happening in the medium?
Well, I would add another one, the fourth one, which I believe it's a visual effect. If you're talking about Coriolis, now if you want to talk about hurricanes and all that, that's a different conversation, Gio. That's not the same thing.
Yeah, but I don't think Coriolis is not only visual. It only is under certain like ideas. Like if you're looking at something from one frame, it can look visual. But it actually does cause like the deflection of like the hurricanes, for example. Like they claim it causes the wind to go from being straight at the equator to like actually making a huge rotation in the north or the south. Like that it actually is. I mean, they call it a fictitious force, but it's like caused by the fact that something is related to that rotating frame. So I don't think it is only visual. I think it only is visual in one instance, but it actually does cause real things. They claim even to move in different ways, like on the Earth.
Well, I guess we can disagree on that because a fictitious force cannot cause anything to move. That's my take on it.
No, it's not. It's the fictitious. It would just be flinging off, right? It's just flying off or something, and another force would then be causing it to actually move, or it would be in apparent motion.
Well, I think there's two things. Like one of them is like just the ball and merry-go-round thing, and I would agree. Like if you have like the two guys in a park, they're throwing the ball straight. You got, they're just throwing it straight, and you got someone on a merry-go-round between them that's spinning around. Yeah, the ball is going to look all curvy to them. I agree that that version of it is just optical, but the thing is, like they do claim that the Coriolis effect on the Earth, when it comes to like the ocean currents and the weather and even the bullet and stuff, like is actually being deflected by something physical. Like it's actually physically altering the paths of the moving air, for example, because it's coming off of a rotating object.
Right. Wouldn't that be a centrifugal force then, and not a Coriolis force? A pseudo Coriolis force?
Yeah, it would be. Well, it's related. It seems to
Yeah,
centrifugal,
bro.
but they still call it as part of the Coriolis effect or whatever. I think they still
The
put it in.
centrifugal is fictitious, also.
That's another thing that they think is fictitious. Yeah, it's all screwed up, bro. They bake people's minds, right? Yeah, they think that is fictitious as well, which is ridiculous, right?
No, I mean it would be. It's like the force isn't from it just flying off. Like it's not. There's no like the figure skater. Goes in a circle. My hands fly out or whatever. You're spinning in a circle. There's no force. I'm not. The force is the torque where I guess my feet are turning or whatever. That's the force. That's where the force is. And then the fictitious that my hands are flying off because there's a resistance to. I mean, there's a lack of resistance holding them towards my body or whatever, so they fly off. So it's not like it's
the force, there's nothing you can't. The force isn't there. You don't point to the force. Say it's right there at the flying ball. No, it's the guy who threw the ball. He put the force in.
Yeah, but if you're on a rotating merry-go-round and it's turning, the centrifugal, whatever, call it a force, call it whatever you want. If you let go, you're gonna fly off, right? That's an actual thing. They call that fictitious. They call the centripetal force the real one, right? The one that makes you go inward, right?
Yeah, as far as I'm aware.
Okay. But the opposite happens. When you let go, you don't go inwards, you go outwards. You see what I'm saying, bro? They got people confused. I mean, what can I tell you? When you let go of the merry-go-round, do you go inwards or outwards?
Going out. Going right off.
Exactly, bro. So as far as the hurricanes are concerned, they have nothing to do with the Coriolis. They say that, it's kind of confusing, people buy into it, but if you think about it, it has nothing to do with a visual, fictitious thing that only works if you're on the non-inertial reference frame. I mean, to me, it's clear cut. I mean, I don't know. I'm not going to force this on anybody. I'm just going to give my opinion on it.
Did you understand the thing I was saying about if you put a ball like the pendulum, you put the arm into a pivot, you just put a little red marks. All right, here's the center of the arm, and then you know what's moving because it's if it's still in the same oscillation plane, then something underneath of it obviously moved. If it's outside of that oscillation plane,
Yeah, that
then
makes
something
sense.
pushed it out. Yeah.
Yeah, that makes a lot of sense. Yeah. You can tell if either something is spinning underneath or if the pendulum is not moving back and forth. I think that's pretty clear cut. Like if you put and that's another thing, right? When they talk about the pendulum, isn't the pendulum? How could the pendulum be moving back and forth? Like these are a lot of things that people don't really take into account, right? Critical thinking. If the pendulum is moving back and forth, how can it be on a rotating globe? It's tied to the ceiling of the building, right? And the building is on the ground, and the ground is turning, right? So
Yeah,
how
I
then?
think that's super crazy. Yep.
You know what I'm saying? No thanks. So, like I'm telling you, there's a lot of critical thinking that needs to go into this stuff, and don't just take their word for it. You know?
Like I might as well stand outside and just flick my wrists like forward and backward and be like, look, the Earth is spinning. Look at that.
Exactly. Same thing. So just the pendulum from the get-go is ridiculous because it's on a rotating frame of reference to begin with. So how could that make a straight line?
I did point out a couple weeks ago, right? You know how the globe guys will say you can't make a straight line; it's impossible. But then they claim that the pendulum it makes a perfectly straight line, no problem. But you can't do it with a level. You can't do it with anything else. But the
Exactly.
pendulums.
Rob's
Yeah.
Rob's on the wall line is impossible, but a pendulum, well, that definitely makes a straight line. Yeah, exactly. Dialetheism, bro. Nothing is 100% provable, but the Earth is spinning. We're sure of that. I mean, come on. Who you know? Now it sounds convincing the way they say it. They fool people. Uh, you know, rotational, non-rotational. They use fancy words, right? But if you think about it logically, I mean, it just doesn't make any sense.
Yeah, even like the whole it's an inertial reference frame. It just either it's moving in a straight line or not moving. That's it. You got to say inertial. I guess.
A lot of people don't even know what inertial and non-inertial means, and when they say it quick, it like baffles their brain. Did he say spinning, not spinning? Is it this? Is it that? Like, you know what I'm saying? But if you sit back and think of it logically, you're going to say, wait a minute, you're double speaking here. How could they say it's a visual effect and then say it actually makes hurricanes turn, right? So they try to tie those things in together with the pendulum too, you know? You can't have it both ways. It's either a visual effect or it's an actual force that can move a pendulum, or it can move well, not a pendulum, because they claim the pendulum is going back and forth. Can move a hurricane, for example. Can't have it both ways. It's either a visual effect or a real effect. And if you have something spinning, that would be the centrifugal or the centripetal force. And I still think the pendulum is a parlor trick, because every time they show it, they say, well, we got to do it a few times, you know? And the other thing I say, they never put two next to each other to show it actually is. So to me, that even that is not proven. And another thing they say is it doesn't process at the equator, the place where it's moving the most. And they never show that in the equator. So I mean,
Well,
these things are all up in the air for me.
it would be a very gentle effect. Like if it was ether drift or earth rotation. I mean, the earth rotation has so many other issues. Like you got to have this gravity and all this other stuff. But if we just kind of go off the basics of it, because like you've seen that animation that I've posted. Have you seen that one that shows it? It's this one. I just found it real quick. This one kind of shows the idea. Like if you take everything else of the globe Earth kind of on face value of gravity and all these other things, that's kind of how they claim the motion is working. That little animation that shows it. So if it was that with a very slow rotating ball or an ether drift that was very slow rotating, we know the sky, like the stars, move very slowly. So whatever the effect is, they claim it's related to this sky movement, except you're on a ball that's moving, which is what causes the sky to move, but it's still a very slow moving. You know, and then when you what is it, like 0.000, you know, et cetera, like revolutions per minute kind of thing. And then on with the ether drift to be a very slow, gentle effect, to have the pendulum be like slightly, just so ever slightly pushed to where it does that precession. I hear you on the equator thing. The thing about that is like you'd have to like technically let it go like so perfectly that it would not precess. And obviously if you gave it any like influence, it would start kind of moving anyways or processing to some extent. So to get that right, like if it doesn't process there, you'd have to like really let it go perfectly straight. But I guess the last thing I was going to say is like I know that you question whether it's a real thing or not, the Foucault pendulum, but if like you would be satisfied like if you had your own pendulum and things and you went to different latitudes, you went to 5 degrees, 10 degrees, 15, north, south, etc. And like let's say within 5 tries you got it to match the latitude. Because obviously it wouldn't be every time. You might bump it a little. You know, we all agree it's such a gentle effect that you could have things that throw it off. But I mean, you would be if you could go to like 5, 6, 7 different latitudes and within 5 tries you got it to match that latitude. Would you say okay, it is a real effect?
I'm not so sure why I would need 5 tries. That's my whole beef with it, because when Foucault does it, right, they don't do it 5 times. He has it and they burn the perfection that you're talking about, right? Foucault figured that out by burning a rope, right? You're burning a rope and it's supposed to go back and forth. So why would you need 5 times? That's
Well,
my whole
you
beef.
may not. You may not. Yeah, I hear you. You may not need 5. You may just need 2 or 3. I guess it just depends on your setup. Like if you've already done the setup several times and you've confirmed that the ball joint is good and the way you're burning it, the materials you're using, the length of the string, like all that, the environment, that there's no like wind or electromagnetic frequencies or sound waves or anything weird. Like, if you've confirmed all of that already, it seems like, yeah, you could probably show up every day and get it within the first one or maybe second. But if you've got other factors, I mean, that one guy, that the video that people post around, that guy, did it himself and he filmed it. It's the one that has like the ink pen that's kind of going on the paper. And I don't know how many times he had to try that. I got the vibe though. I don't even think he was like a flat Earth, globe Earth debating guy. I think he was just a dude who did it. And I mean, I got the vibe that he put the materials together. He went into that stairwell and he filmed his video. Like I don't get the vibe of it that he had to do it 100 times. But I don't know. Obviously, I didn't see the background of his video, but he seemed kind of amateur. So I hear you. You might not need to do it 5, but within 3, within 2. I mean, like I said, I guess it just depends on whether you've already vetted all the materials. But I mean, yeah, it seems like there could be some things that would throw it off, conceivably, even if you have it all set up right.
Yeah, I see what you're saying, but like I said, I'm not convinced of this. I would have to see it for myself, and I would like to see like my thing with 2 of them side by side, right? That would be like really something. I don't I don't think they would both show the same thing.
All right, but
yeah.
But if you did do 2 side by side or even 3, and they do it, pretty consistently, granted there might be a few misfires or whatever, and then if you did that at different latitudes multiple times, like if you did come to the conclusion, okay, it is a real effect, I would assume you're not going to jump to being like, oh wow, we are on a rotating ball. Like you wouldn't, like what would that evidence be if it was real? Like would it push you towards we are on a rotating ball, or would you be like, okay, it must be ether or something else, or would you just not have an exact conclusion if you knew the effect was real?
That's a good question. Yeah, I wouldn't automatically assume that it was a rotating Earth. Then I would think, magnetism or whatever. But I would be shocked. Like I would say, oh boy, okay, there's something to this now. So at this latitude, it's making this shape. At that latitude, it's making that shape. And if it's doing it consistently, then I would be a fool, lying to myself if I didn't think some effect was there, right? So yeah, definitely, I would, I would reconsider my position and take it from there. But I wouldn't say, aha, it's Earth curve, Earth rotation.
Yeah. Well, because it's funny because the globe guys are trying to say that it is proof of it or shows that it is rotating, which is also an absolute claim that the globe is absolutely rotating. But nonetheless, without going the whole relativity kind of thing. So, I mean, even if you saw that it was a real effect, it's not even going to compel you to be like, to think it's the rotating Earth necessarily. So it's kind of funny that even if their effect was proven to you, and I think many others would hold your similar position, that even if that effect is proved, it doesn't actually even indicate that you're on a rotating globe.
Yeah, further investigation needed. That's what I would say. Yeah.
I'm telling you, an accelerometer and a Foucault pendulum. You get that left to right force. Like there should be no force there if it's Coriolis. Like there is no real force making objects deviate in Coriolis. If it is how they say it is.
Well, it's the rotating ball.
Yeah, but when there wouldn't a force wouldn't be registered on the thing on the pendulum.
It's just a deviation in relation to the rotating body. That's all it is.
Well, that's what they claim it is, but you would agree that to have a stationary Earth, that actually there is an actual force that's causing it?
Oh, on Earth, there is no Coriolis force. Definitely not, because Earth is stationary. But they conveniently conflate it with the 15-degree Sagnac effect, whatever the rotations are that are in the north and the south, because of the sun movement and the heat and the sidereal rotation and all that is being affected in a slight, readable, translatable motion, clockwise and counterclockwise, going along with the star movement in the south and the north. Right? That's very slight. It has nothing to do with Earth rotation. But
yeah, but do you think it's a real force, like ether drift or something?
Yeah, that's the thing. That's what they actually detect. That's probably why they had to say it was rotating at the degree that it's rotating, because that is an actual measurable effect. Like if you look at like the GIF I'm about to post here, if this is what is actually happening, we have a stationary Earth with a northern and southern rotation of the sidereal movement over a stationary Earth, right? If you there it goes. Okay, so you can see that, right? If that's what's happening in general, right? Because of the sun movement goes through the celestial equator area, it goes either north or south, but it creates these whirlwind type effects of the ether or whatever it is, as well as the sidereal rotation. It all moves in that direction, clockwise and counterclockwise. That's what they're detecting, right? So it has
Right.
nothing to do with Earth rotation. That would be a real quote unquote force because it's detected. But they conflate that with the idea of the rotation, and they can show it with the hurricanes and the weather patterns and all that because that's real. But as far as the Coriolis effect goes, if it's over a merry-go-round, yeah, the ball goes straight, but it's always in relation to the moving body underneath. So if you're looking from space and you were able to draw the path in relation to the body underneath, it would be a curved path because the body underneath is rotating. That's where the curved path comes from. Even though it would look straight, if you could actually trace the path would be curved. That's the Coriolis effect, right? Then there's the Coriolis force, as if you were on the ground or if you're just measuring it from the ground, there would be a quote unquote pseudo force because it's causing a deviation in relation to the ground. It has nothing to do with the plane actually moving or the ball actually going in a curved path. It's just in relation to the ground. And then when you talk about the inertial versus non-inertial reference frame, both those reference frames, they love to talk about it as inertial versus non-inertial because both of those are moving and it assumes a spinning Earth, right? We have to have an absolute reference frame, which is what we actually have because the Earth is freaking stationary. So they don't ever talk about an absolute reference frame. That doesn't exist in their relativity-tard minds. They can't.
Yeah.
It can't
So
exist.
So you're kind of like the image you posted, which is a really good one. I like that. It's just really cool looking. And instead of like showing the stars, it's showing almost what looks like wind or whatever. So it kind of has like an ether drift, ether wind kind of look to it. Just that graphic. So are you kind of suggesting that calling it the Coriolis effect or Coriolis force is like a misnomer?
Yep.
Because yeah, because it's not actually deflecting because of Earth rotating under it. It's
Yep.
actually like it would be an actual real wind or drift or swirl
Exactly.
that is actually
Has nothing to do with rotation of the Earth. This is why they call it Coriolis force, and they're happy to talk about Coriolis if you're giving them Coriolis as if it were actually happening with planes and arguing, if it were how much is happening or whatever else, because it's not happening. The Earth isn't spinning. So as long as you're playing in their playground, they're happy to argue with you forever about it because you're assuming the Earth is spinning. There'd be no way to correct any kind of flight that goes west-southwest, by the way. I mean, if you had this flight, like this picture I'm posting here, how if they were even talking about correcting, they always have to have it work both ways for them too. With like, oh well, the plane's correcting for it, and that they stay on their path because they're correcting for it, and they're going faster eastward in that eastward vector, which is completely separate from the forward vector if it were rotating. But there is no rotation, so there is no other vector. There is only one vector. But if the Earth were rotating, there'd be two vectors. It'd have to keep up with the Earth eastward, tangentially, and move forward freely at whatever speed it's moving forward without that eastward vector affecting it, which doesn't even work because both vectors would be combined. You have to have vector addition. You would have to actually move the plane faster forward to go faster eastward, and that never happens. And it can't correct if it's going west-southwest. It can't correct backwards to go eastward faster. So the Earth isn't spinning, and that's why they love to argue forever and ever as if you're correcting or not correcting. And this 15 degrees that they calibrate their their gyroscopes to go with when they get on the plane, which is just correcting for that drift that we detect, which is that 15-degree rotation and then south of the north, counterclockwise as opposed to clockwise. Has nothing to do with rotation. There is no Coriolis force on Earth ever. It's just a conflation with the Sagnac effect or whatever it is, that sidereal rotation that they're detecting slightly. And if you go faster south, it would be totally fucked up. There's think about a jet that flies 1,000 miles an hour. You think that that's correcting eastward or being forced to go eastward by some atmosphere? You know, it's so stupid. It's ridiculous and stupid when you really calculate it out. Like just no way that a plane or a jet that's going at 1,000 miles an hour or has 40,000 pounds of thrust resistance or going against the spin is forced backwards to stay up with the Earth rotation when it's 1,000 miles an hour at the equator, and they could be going from zero. They could be going all over the place, and they don't even need to correct. They could have no path. There could be no path whatsoever. It could just be a joyriding pilot. As soon as you take the path away, they're fucked. Because if you say it's a joyriding pilot just going in circles all over the place, he's not correcting for anything. But he's always going to be able to land in some random field at the equator where it's twice as fast or 1,000 miles an hour faster. He's always going to be able to treat it as stationary. The only way that's possible is if Earth is stationary. Atmosphere pushing the plane to be going 1,000 miles an hour eastward in that vector, but then going 100 miles an hour forward still. And then it continues to carry the plane at 1,000 miles an hour in such perfect sync that it could just treat the Earth as stationary still when it's landing facing the opposite direction of the spin. It's ludicrous. I mean, it's insane and not even probable or possible.
All right, so I understand some of like what you're talking about when you have a rotating ball, like what would be required, like if you were actually on a ball that was rotating like that. But like just as a quick interjection, like if you do think there is a Sagnac effect or a drift, what effect is that drift having on airplanes, if any? Is it having any effect? Like that swirling of that image you just showed, is that having any effect on an actual plane, or do you think it's just so minimal? Or
Well, if they do make a correction or a calibration for their gyroscopes, it would just be affecting the gyroscope for their, their readings, so they can stay completely, uh, separate from whatever that Sagnac effect may be causing on their instruments. They're just negating that slight Sagnac effect, which has nothing to do with accounting for 1,000 miles an hour eastward rotation. So it's like total, like it's like when they say, "Oh, you don't feel it when you're on a plane going 500 miles an hour forward in one linear direction." So you could be going in big circles at millions of miles an hour. It's the same thing. It's just like taking one little small thing and then making it work for the larger, incompatible possibilities. I mean, do they actually calibrate their gyroscopes when they get in the plane? I'd imagine that would be the case because we do have some kind of effect on sensitive instruments with that sidereal rotation.
So, new perspective, you think there's an actual something that causes a pen to show what it shows? You think there's an actual force or something there?
If there is, if pendulums are affected the way they say, that would be, the same exact thing they're detecting. Yeah. I mean, they see it with the Michelson-Morley with the interferometry. That actually seems to be like there is a drift of some sort with the wind. It's an ether wind or whatever you want to call it, and they just conflate it with Earth rotation. But it wouldn't actually force the plane. That's the thing. Like you're saying, Gio, I think that was more your question. Like, would this ether wind actually be able to move the plane? No, the ether wind's not going to force the plane to do anything. It's so slight. You can barely detect it. it may mess with their instruments to make sure, as far as their readings go, a sensitivity of the readings. And that might be important to make sure they're going in a straight line, point to point, without any rotation, which is what they do. There's never, ever, 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 ever a Coriolis effect with planes and balls spinning, ever. It would be
Well,
so
don't.
noticeable. It'd be so obvious that was the case. We would never be able to land, Bob. We'd never be able to land a plane to begin with.
Well, let me ask you: that the 15 degrees an hour, or the sidereal motion, which they claim is Earth rotation. Let's just say 1,000 miles an hour. Isn't it the case that the ether drift or ether wind, if it is related, would also be going 1,000 miles an hour? Because if it's going with the stars are going at about 1,000, give or take. Because like the sun at the equator, 1,023 miles an hour, like over a stationary Earth, like 15 degrees an hour. I mean, if it is 24,000 now, there's that, it involves that
Yeah,
circumference.
that's a good question. Like if you translated it into miles per hour, as far as like does it have to get faster going up from the North Pole to the equator and down to the South Pole? If you could measure the difference, and then that's where it comes into like, we're just measuring a 15 degree no matter where you are. But who says it's 1,000 miles an hour or not? Yeah, that's a good question to figure that out. Like if you translated it into miles per hour, as far as like does it have to get faster going up from the North Pole to the equator and down to the South Pole? If you could measure the difference, and then that's where it comes into like, we're just measuring a 15 degree no matter where you are. But who says it's 1,000 miles an hour or not? Yeah, that's a good question to figure that out.
Well, I'm just saying, when you're talking about the 1,000 mile an hour of the Earth, is the Stagnac effect? Is it not 1,000 miles an hour itself?
I don't know. I mean, I can't say. I haven't even figured out if that would be a way to like measure one ether drift compared to another, because the way they measure it is just 15 degrees. They don't measure that in miles per hour. If they could.
Yeah. I mean, it seems weird to think 1,000 mile an hour ether wind would cause a pendulum to just very slightly trickle, just shift a tiny bit. If it was literally like, if you were standing there and there's 1,000 mile an hour thing, neutrinos or whatever, just shooting in front of you. I'm kind of joking saying neutrinos, but
Yeah.
an ether drift thing that was, neutrinos could be connected to ether actually.
Here's the cool part. And here's the cool part. At the equator, where your 1,000 mile per hour ether wind is blowing, there is no drift of the Foucault pendulum. The Foucault pendulum drifts the most at the North Pole.
It's because it's going straight. Yeah, but that would be expected with an ether wind, and the ether wind is it's not air necessarily. It would be involved in the medium. It's related to the star motion. But yeah, that would make sense because it's just going straight at the equator. It would not be expected.
Except that if you then go 90 miles, if you swing the pendulum, let's say east-west, and the ether wind would be east-west, it would not precess. If you swing the pendulum north-south, directly opposite or directly 90 degrees to the so-called ether wind, it would also not precess. So
theoretically, I don't think that's been shown.
Actually, it's been shown at 5. The closest to the equator Foucault pendulum I can find is at 5 degrees, and it shows exactly what you would expect at 5 degrees.
That's interesting that it actually would slow down at the equator rather than speed up.
Which is directly opposite to your ether wind. By the way, this whole ether wind
directly opposite of the rotation, in fact.
Yeah, directly opposite.
Say it again. Wait, what's opposite?
It's opposite.
He's saying it slows down to 5 degrees, from 15 to 5 degrees towards the equator.
No, at 5 degrees, the closest Foucault pendulum to the equator I can find is at 5 degrees north, I believe. I have to look up again. And the rotation of that pendulum is exactly what you would expect. It takes like almost a week to make a full circuit or something like that.
Yeah, but that makes sense because as the lines are getting straighter towards the equator, like in that graphic that New Perspective posted, it would have a less of an effect on the pendulum, even though the speed, that's fine if you want to say it goes from 900 miles an hour to 950 to 975 to 1,000 as you get closer to the equator. But the thing is that the lines are just like the stars. The lines are getting straighter and straighter. So but the lines that are very circular are going to cause more of a precession because the ether drift.
Well, they're weaker though. It's just like the ether wind would be zero at the poles. It would have no. Yeah, you really got I mean, you've really stretched out for this one to say
No,
that
it would,
where the
why would it
winds
be
are this.
zero at the poles? It's making very tight circles.
There's no ether wind at the poles.
Why not? It would
There is
be
ether winds
making
at the
very
poles,
tight circles in terms of what a
but
pendulum would do. Yeah, just like the stars are.
yeah, but if it's 1,000 miles, according to you, if it's 1,000 miles at the equator, it would have to be 0 at the North Pole. That's what you would say, because your ether wind is
Yeah.
basically
Okay. Well, if
the
you're talking about, are you
counterpoint to
talking about,
rotation.
you're talking about
So I
under
want
the X, like at the pole, or you're talking about around it?
well, at the pole. By the way, they did do a focal pendulum at the South Pole a few years ago and got the 24-hour rotation they expected.
Yeah, that would be expected with an ether
No, I don't think so.
drift effect that's related to the stars. Like, if you're right at the equator, potentially it would be, or at the pole. I mean, sorry, if you're right at a pole, one of the poles, potentially it would be 0. But the thing is, like, is that one point, or is it like a region? Because if you had a pendulum swinging, it's not at one point; it's already going 10 feet or whatever swinging.
So
So
you think
how could you
so there's
ever
gonna
be really right at it unless like the pole is claimed to be like an entire region of all area where it'd be 0?
so you
Technically,
think that
point.
10 feet plus or minus, if we're right at the pole, let's imagine we're right at the equator, in Quito, and we're swinging 5 feet to one side and 5 feet to the other side, that would the ether wind going 1,000 miles per hour would be like what 999.99995 feet away, right? You think that would make a big difference?
Well, I was saying the pole. I was saying something different, but to what you're saying, that would be expected to be an extremely minimal difference. I guess on a globe
Exactly.
or an ether drift kind of viewpoint, it would be like
Well, think about your ether drift.
I mean, what do you think? 5 feet, you're going to pick it up
No,
to
no.
when do you start picking up drift then in your belief that
Well, you
you've
see, the
never
thing
tested?
about it is this whole ether wind concept, where the ether wind is the strongest, according to you, the focal pendulum drift is the least, and where the ether wind is the weakest, the focal pendulum is the most. So it's kind of backwards from your ether wind definition of moving the pendulum.
Oh, I don't agree, because I mean that's not relating to what I'm saying anyways. If that's someone else said that, it could be different.
Well, no, I mean this is the map that he
Yeah,
posted. You just said it would be 1,000 miles at the pole, but yet that
Oh, he
causes
was
no drift.
asking, would it be? He
I mean, at
wasn't
the
saying
equator,
it would be.
1,000 miles at the
He was
equator.
asking if it would be. He wasn't saying it would be.
I just think
Yeah,
you're
I was
all
actually asking him if he thought, like, because if the ether drift is related to the stars, and the stars are moving at, let's say, roughly 1,000 miles an hour, they're a little different than the sun of sidereal versus solar day, but like everything in the sky would be generally moving about 1,000 miles an hour. I mean, less as you get to the poles because they're covering less ground, and so it would be the same. Like, the last thing you had said, NASA Shill, I just don't agree. Like, I just reposted the thing Dave posted. So even if you have, like, let's say that was the ether drift right there, like, even though it looks like clouds or whatever, it looks white, let's just say that was it or something. At the equator, yeah, it would be moving the fastest along the ground, but it would, because it's going straight, if you're talking about a pendulum, it would not be affecting the pendulum very much because it's going straight. As you were to go north or south, even though technically those circles are going slower, actual speed wise, well, they're still doing 24 hours in a day or whatever, but the same rotational 15 degrees an hour maintains, but the actual speed along the ground, like whether you're going 1,000 or 800, 700, 600, 500, as you get closer, obviously those circles right at the pole, they're not going 1,000, they'd be going very, very slow. And so, yeah, it would be expected that to have the pendulum drift related directly to an ether drift, it would be make sense. It would actually match pretty much what the globe claims. Like, as you get further to the pole, it would
but where the ether wind is the strongest at the pole, at the equator, it causes no effect on the pendulum. But where the ether wind is the weakest at the poles, it causes the most.
because there's two things involved. One of them is the directional path. Like, even if you have 1,000-mile wind at the center, I don't really like calling it a wind, I'll call it a drift. If you have 1,000 miles, but the thing that causes the pendulum to precess is the ether drift, in this case, would have to be curving, would have to be turning. So at the equator, even if it's going 5 million miles an hour, if it's going straight, it, in theory, would not affect the pendulum. Whereas even, what I'm saying? There's two things. There's speed and the amount of which it's turning, the size of the circle. There's two factors. So
Well,
just like
if I take
if
if I
you're
take the
going, if
pendulum,
you're going, like, if, just real quick, sorry, if you're going straight at 5,000 miles an hour in a car, whatever the fastest land car is or whatever, and you're going dead straight, you're not going to be thrown up against the wall left and right. But if you're only going 5 miles an hour in a car and you turn really hard, you'll get thrown up against the wall. So there's two things involved. There's the speed. And now I know that's centrifugal, but it's related to Coriolis, but it is centrifugal. But there's two things. There's the speed at which you're going, and then there's the amount at which you're turning or arcing. So the amount of arcing of the ether drift, let's say if it's connected to the stars, at the poles would be very, very tight, even though the speed would technically be slower upon the ground, but that tightness would be the thing that causes the pendulum to drift.
but if I swing the pendulum directly perpendicular north-south to this ether wind, it would also not persist. I don't know. It seems like you really
Wait, if you did a north-south at the equator, you mean?
yeah, a north-south pendulum at the equator would also not persist, even though it's directly
Well,
sideways.
that's actually a good question. You also have the Eötvös effect, which is kind of related to this, at least on the globe model. I pronounced it right. Yeah, Eötvös.
Yeah, it's Hungarian. Just do whatever you just makes like mouth sounds and then in Vos, I guess.
I probably said it too Americanized, but maybe
Yeah,
you don't
but no,
pronounce
Hungarian is a tough language. I'll give you.
you don't pronounce the E or whatever it is. Eötvös.
Yeah,
Whatever it is.
Utvos or something like that.
Eötvös. That's my best Russian accent. All right.
Yeah.
Anyways, yes, whatever that. So it's related to that, but I mean, dude, this is the thing. I guess if there's never really been a Foucault's pendulum tested at the equator, do you know that it does or doesn't precess if you start it
Well, like I say,
going east? You're saying if you start it, are you saying being dead on the equator and you start it going east to west versus start it going north to south? Is that the polarity here, or that you're asking?
Correct. Yeah,
I don't know. Has anyone ever done? What do you expect on the globe? You're saying it still wouldn't precess if you do it north or south?
It's correct. The direction doesn't matter.
But you've never tested it.
Well, like I said, the one I can find the closest is at 5 degrees, it's at 4 degrees, and it has the period that you would expect of a pendulum at 5 degrees. I don't think anyone's built a $10,000 Foucault pendulum at the equator just to see it not precess.
Well, but it's even more. You're saying the difference, like the ether drift. I mean, first of all, the ether wind or ether drift, how it actually functions. It doesn't necessarily mean that it functions like a wind. That's like somebody blowing air. In terms of how it actually works, like in the medium. So I'm saying it could be a conflation there, or possibly strawman. Although I know you're not necessarily trying to strawman, but to think of it, and I realize that image that was posted, it does kind of look like it has all those directions. It almost looks like a wind, and we were kind of using that as an example. But I do hear what you're saying, that if you did have a wind like that, if you were to start it going north to south, you would expect.
Yeah.
Would you not expect a deflection though, because you have the ether wind on the north side of it and the ether wind on the south side of it, and would they cancel? That's kind of tricky.
I don't know. This whole ether wind thing is against Michelson Morley.
Well, I mean, dude, you're already up on the new paradigm stuff, so you're already. It may not seem like the paradigm and the whole world is going to shift, but it will in our lifetimes, and you'll be. You're already onto it. You're already into it all, at least, or at least aware of some of the foundation.
Take care of my dog. Be right back.
And I mean, ether's not new either. Ether is we came from ether and a planar stationary Earth, all of humanity, and it was turned into this globe thing. So it's not really new, really, but it's a reviving of what has existed since the dawn of time, outside of this globe relativity thing that has just come in the last 100 to 200 years. It's crazy when you think how recent. Like, I just looked up today, like Georges Lemaitre, the guy who apparently invented the idea of the Big Bang. He was born in 1894 and died in 1966. Even the Big Bang is really recent, and a bunch of people are believing that that's their origin story, but it's 100 years old. Even if it was true, it's 100 years old by a Catholic priest who just came up with it. So a good portion of humanity right now think that their origin story, generally goes with materialism, atheism, all that goes with the Big Bang, and it's 100 years old. Catholic priest just came up with the idea, and he's got all these people believing it. A good portion of the world through this whole paradigm. So it's all pretty new in relation to the history of humanity.
Which is what they're supposed to do, right? you would have to think that there's a force pushing it from the side, right?
Yeah, like basically, I just found this image real quick that kind of goes with with this pretty well. So the thing on the left, that would be like a pendulum setup. Let's say that was a stairwell. The blue thing would obviously be a cable. You know, you'd have a weight at the bottom, and then it makes that kind of flower-looking type pattern, which actually looks like a dandelion. Looks like a dandelion flower. Because this is all in nature. I mean, this is like Fibonacci, golden ratio. It's all related, but yeah, like basically it would have to be that yes, something is actually, whether it's like something built into the medium, whether it's built into the matter, or whether it's an outside force, I guess however we might like think about it or define it, it would basically be that like in that image I posted that yes, something is actually literally causing the blue line or the actual pendulum. Like you said, if it's whether it's pushing from the side. Well, like that's what I'm saying. If it's like an outside thing, it'd be pushing from the side. If it's in the matter, it would just be built into the matter. If it's built into the medium, you know what I'm saying? There could be a few possibilities there.
Right, I see what you're saying. So now that made me think of something. So picture that blue thing, the blue string that you put there. That's a string, and picture the ball on the bottom is a paint can. You must have seen those where those painters get a can, they put a hole on the bottom,
Yeah, it's pretty
and they
cool.
let go, and it traces lines, right? Back and forth. We've all must have seen that, right?
Yeah.
Okay. So now, if that's the case, and it's either the earth turning or what you're saying, there's some sort of ether force, quote unquote, for lack of a better term, then each time you let go of that paint can, assuming it's not gonna wobble on its own, right? I mean, you cut the string like Foucault did, right? Then you would have to assume that every time you do that at that same spot, the paint would draw the exact same shape, right? You, you
Yep.
realize that, right?
Yep.
What do you think the chances of that happening are, though?
I think it does it. I think you could probably get it like if we I mean it all depends on the precession rate of what the painting is going to look like. Like this
Oh, but
one, which
assuming you have the
I'm just
same can, the same length, you know what I'm saying, like always
well,
the
like
same.
so I guess what I'm saying, I just found this image that I don't even know if it exactly is, but it like the shape that it draws on the ground will be different based on the latitude is the claim, and is what is goes along with this. So
Exactly.
like if you were in the same place, like if we had a big warehouse and we had no wind blowing, no electromagnetics, we don't even have Wi-Fi, it's as clear as we can be. We set up 2 pendulums, maybe even 3, hang them from the roof, whatever we have to do to reinforce it or make it all so it's like as ideal as possible. And then you have a big warehouse. And if you had 3 of them going or even 4 or 5, whatever you want. And then if you have big sheets of paper on the ground and then you have ink and you're going to have it, draw the ink basically, or you're going to have it kind of make the shape or paint it on the ground. Yeah, I think you could get all 2 or 3 pendulums to paint that latitude's little flower design pretty consistently. Like it probably.
So you said 4 wobbles, all a different race. Well, I think you're lying, no matter what you say. I'm cherry picking interpretations that make me trust I wasn't taken. And no matter what you say, you must be lying. Or all those spaceships that they be flying, they never really went to space. No steps for man or human race. No ISS with water playing people on a twin tower solar panel eagle, speeding 10 times faster than a bullet. And in 2030, they're gonna pull it. But take a look at the path, it's not an orbit. It makes the flower of life, it's sacred geometrical. Ptolemy saw how beautiful, and all the wandering stars, they make this pattern too. It's all up and even me and you. The fingerprints of God and Fibonacci, and all plants and fruits and nuts and seeds. So why not just call it like it is? Just like we call it like it is. We always call it like it is. So why don't you call it like it is? Like it is, like it is, like it is. Not the opposite of what it is. Aimed intelligence, our essence of connecting us, creatively developing, eternally enveloping it to itself and out again, toroidally oscillating with primer feels a point elating. And it's like the whole of us is keeping track, thinking all collectively. It's because of every you and me, perpetually. Just like we breathe, we breathe, we breathe, we breathe, hailing and exhalating. No ISS. So why not just call it like it is? Just like we call it like it is. We always call it like it is. So why don't you call it like it is? Like it is, like it is, like it is. Not the opposite of what it is. But all believers, they just can't breathe unless they're trusting that someone knows. All the answers to what you say is impossible, not merely just improbable, or even close to plausible, and not probable at all, at all, at all. Ridiculous and laughable. 4 wobbles about to make you fall, make you fall, make you fall, make you fall. No, you're not wobbling at all, and you're not on no damn ball, no damn ball, no damn ball, no damn ball, no damn ball. Not merely just improbable, or even close to plausible, and not probable at all, at all, at all, at all. Ridiculous and laughable. Before wobbles about to make you fall. 'Cause you ain't on no damn ball, no damn ball, no damn ball, no damn ball. Everything's intelligence, our essence that's connecting us, creatively developing, eternally enveloping it to itself and out again, toroidally oscillating with primer feels the point elating. It's sacred geometrical, but Tommy saw how beautiful, and God's golden ratio spiraling in all plants and fruits and nuts and seeds, and in you and me. So why not just call it like it is, like it is, like it is. Not the opposite of what it is. They say it's 4 wobbles up the ball, and that would be impossible, ridiculous and laughable, 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 and not a ball at all, at all, at all. 4 wobbles gonna make you fall.